Good morning, everybody. I've just lost my notes, so I'm going to ad-lib this bit. Welcome to the second day of the NHS-R conference. It's going to be another wonderful, fun-packed day, I think, with lots of great talks. My name is Zoe Turner. I'm a data scientist at Nottinghamshire Healthcare Foundation Trust, and I'm an immensely proud fellow of the NHS-R community. I would just like to say that this conference day, as the other ones are being live streamed on YouTube, and they'll be there later for watching and catching up later. And we also have a chat function for questions or discussions, which you're encouraged to use today. But I'm not going to talk any further because I just want to get on, and I'm sure you do too, to listening to the talk. So I'd first of all like to say, I've said good morning, but I need to say good afternoon because our first people today talking are Gillett and Andrew Johnson, and they're coming to us from Australia. So very much welcome that. They're from the Patient Safety and Clinical Quality Directorate in the Government of Western Australia, the Department of Health. And they're going to do a talk on Down Under, which is a very good pun, our journey using R for quality assurance in Perth, Australia. So welcome, Rich and Andrew.
Good morning, and thank you for having us at your fantastic conference, and good afternoon for anyone tuning in from Australia. Hopefully there's more than just the two of us. So my name is Andrew Johnson, and I'm here today with my colleague Rich Gillett to talk about our journey in safety and quality methods and using R to help with those methods in Western Australia. So before I get into it, I just wanted to quickly acknowledge the traditional custodians on the land upon which I'm meeting today, which is the Whadjuk people of the Noongar Nation, and pay my respects to their elders, past, present, and emerging. So for those of us that aren't aware, in Australia, we like to start our formal meetings with an acknowledgement of country of the Indigenous traditional owners of the land. And Indigenous and Torres Strait Islanders can also start meetings with a welcome to country. So to give you a bit more background about who's talking today, leading you in at the moment is myself. I'm the statistician in the team. I come from a background in Bayesian statistics and psychological research. You might have seen me in the STAND forums if you've ever delved into that area of Bayesian statistics. And I'm supported here today by my colleague, Rich Gillett, a senior analyst and also a transplant from the NHS who's been key in introducing a lot of these safety and quality methods. So we're quite happy that we stole them from you. So I'll now pass over to Rich Gillett to run you through our journey.
Hi everyone, I'm Rich Gillett, and thanks Andrew for the introduction. Just a few quick facts about WA, Western Australia. Population about 3 million, so that's about the same size as the UK. Sorry, about the same size as Wales. The inpatient split is about 55% private. In WA, we've had almost no community COVID, and in total, we only actually had about 420 cases altogether. So we've been COVID-free for over a year, which I know is a real contrast to colleagues who've been working really hard in the UK. Our role at the department is to monitor safety and quality, so we do that through a series of indicators. Our health system is doctor-led, so most of the senior leadership positions are held by doctors, and there's no koalas here in WA. They're all over on the East Coast, which is where Sydney is, but we do have these little guys, and these guys are called quokkas, and they're very cute, and they permanently smile, and you'll see them throughout our presentation today because they are joining us. So in safety and quality, as many of you know, often we report indicators, and we typically used to report this old way of presenting measures, which was using red, amber, and green. It's a great way to convey information really quickly. So executives who are time poor really like the red, amber, green scoring system. And we usually produce packs several hundred pages deep for our senior executives to read on a monthly basis. But our journey has been moving away from that. So we've moved away from RAG scoring for quality measures, and we're using funnel plots and SVC charts. We're big fans of Edward Stemming. We actually have a picture of him in our office that you can see where we've made him up as a saint because he's influenced so much of our work. So we started off on our journey from RAG to funnel plots and SVC just by sketching. We created some wireframe sketch diagrams about what we wanted to produce, and we did this work in partnership with our performance team. We did a pilot, a demo, went for some low-hanging fruit in terms of some easy indicators that we thought were really ripe for presenting in the way of funnel plots and SVC. Sadly, Chris Hemsworth didn't join us, but he has been here for a Quokka selfie too. And we had this balance around, do you go for the pure SPC subchart types? Do you go for funnel plot distributions where you can choose from a wide variety of distributions, or do you just actually go for something really simple and really clean to get it across the line? And so we did start off with a very pragmatic approach to introducing SPC and funnel plots, but we acknowledged that that wasn't statistically pure in that sense. And this was a quote that we really kept in our minds, that actually just to get people across the line, that perfect was the enemy of good just at the start of our process, and gradually we would move along. So we built a platform, custom built in a .NET Core and C#, I think, where we introduced funnel plots and SPC charts for the very first time. And then we also had a bar chart on there just for those people who wanted to have the original chart. And where we are now, we've moved to incorporate 31 indicators, some of which were in the performance arena previously, and we're using RAG scoring. But we use SPC and funnel plots to monitor and measure those. We've been heavily influenced by a modified quality surveillance group model. So all of our indicators are reviewed by multidisciplinary teams, not only where we look for patterns, but we also bring soft intelligence and we triangulate certain sources of information together. So they're in use not just only inside the department, but across many of our hospital trusts or the equivalent of hospital trust boards. And we're just at a point now where we're taking a bit of a project selfie, like Roger Federer, and looking at where we've come to, how we got here, and what the next couple of steps might be. But Andrew's just going to talk a little bit over the next couple of slides about how we got in detail to this step using Power BI and R. So back to you, Andrew.
Thank you very much, Rich. So our journey has been iterating through 4 different products. And as we've iterated through these different implementations, we've gone through these cycles of plan, do, study, act, these repeated evaluations. We've slowly refined that balance of statistical rigor and accuracy, but also ease of use and user accessibility. And you can see our little Quokka friend has been increasingly happy throughout this process. So we started off, as Rich mentioned before, with just a custom web application where we manually wrote and re-implemented these funnel plot and SPC methodologies. The eagle-eyed amongst you might notice that these aren't statistically perfect or rigorous, because really the goal here was to introduce these safety and quality methods and control charts to the wider WA health system, increase statistical literacy and accessibility and uptake of these methods before we start that transition and that journey towards more statistically rigorous methods. So this was our first implementation using, as Rich said, .NET Core and C#. Following this, we transitioned to an application using Power BI, because it's much more flexible, much more power, and gave us quite a wider range of methods to use in our toolbox. So the next iteration, we again took the approach of re-implementing the funnel plots and SPC charts, this time using DAX. However, we did find this process to be slow, very manual, very tedious. And again, we're essentially just re-implementing the rewriting code that other people have done in other languages, which means that we're taking that maintenance burden on ourselves, dealing with any technical debt, and it's up to us to catch and fix any bugs because we don't have that wider community using and testing these methods. So it was at this point our little Quokka friend popped up and said, well, where's our R? What are we doing? So that it was at this point that we took a bit of a step back and we thought, let's have a look at what's going on internationally and let's have a look at what best practice is at the moment. And it was really at this time that we came across the work of your community in NHS-R, the fantastic people in HexiTime, NHS Scotland, Future NHS, and all the people that give up their time on Twitter. And really get to see how these methods can be used, the various implementations around the world, and just this ability to engage and interact with experts and leaders in the field. So really from the bottom of our hearts, we'd love to say thank you to everyone in this community for your support and engagement at this stage, because it really helped get us over the line to the next iteration of our project. So it was at this stage that we started to incorporate R into Power BI. So there are a number of statistical packages in R for these kind of control charts, things like funnel R, funnel plot R, QI charts too, some of the authors of which are in the audience at the moment. However, we quickly ran into a stumbling block where to publish a report online in Power BI, the Power BI service needs to have that R package available. However, this wasn't the case for several of these packages, namely funnel plot R and QI charts too, which were our core dependencies. So we had to have quite a tedious workaround of copying the entire source code of the package into a visual and then uploading that. So this was slow, it was tedious, and at the end, we just had a static image. It wasn't interactive, it was to a very limited extent customizable, and it really hindered that user engagement and accessibility that we really wanted. So it was at this stage we took a step back and took a different approach. So still using R, we started to pre-calculate the limits externally and then upload the pre-calculated limits to cloud storage, in this case Snowflake, which are then pulled down into Power BI, formatted and presented in the web application that you see there. So we're using the funnel plot R package from Chris Meaney and the QI charts 2 package from Jakob Anhøj. I have butchered that name, so I'm going to apologize very deeply. And as you can see, this made our little quokka friend at the top very, very happy. So we've now made this transition from traditional RAG reporting to be able to use these funnel plot methods for comparing hospitals cross-sectionally and SPC chart methods for comparing a hospital's outcome or a group of hospitals' outcomes over time. So where are we going from here? So at the moment, we have a series of R scripts that we're using for screening these pre-calculated limits for outlying hospitals or individuals that meet particular decision rules. And we're in the process of updating these scripts to use the NHS rules used in the Plot the Dots initiative. We're putting in a lot of work optimizing this pre-calculation process through parallelization and offloading to cloud compute. And we're also looking into alternative ways of presenting and interacting with these results through things like static reporting in R Markdown, or more interactive options through things like Flex Dashboard or a Shiny app. And even further into the future, we're looking at pure Power BI implementations. So we've been developing custom visuals in Power BI for these SPC and funnel plot methods. They're completely free to use, open source and freely available, and they allow a greater level of accessibility for these methods for clinicians and analysts that might not be familiar with R. So here's some quick examples of the visuals that we've been developing and starting to use. It's a simple drag and drop interface for your numerators and denominators, and you get interactive funnel plots and SPC charts, as well as adjustments for over-dispersion and just a wide range of chart types available. Very, very accessible and very little user knowledge required. So we're quite excited about these. Now, if you had any more information, if you had any questions about anything we've talked about in this presentation, if you wanted to get your hands on the custom visuals, or really just want to talk about anything safety and quality, feel free to get in touch with myself or Rich. And if you yourself are interested in getting a bit of a break from the NHS or doing something different for a little while, quality improvement skills are on the visa list. So if you're interested in a break, we would absolutely love to have you over here. And so again, feel free to get in touch with any questions. Did you have anything to add, Rich?
That's it. Thanks very much. I guess we'll open up to any chat that Zoe might want to facilitate or any questions.
I'm not sure I'm showing on screen, but yes, I am there. Yeah, there is a question. Does Power BI have integrated version control for development?
Power BI does not, but the visuals themselves, if we're talking about developing visuals, they're developed in a language called TypeScript, which is a modification of JavaScript, and you can use regular source control and versioning through things like Git or GitHub. As for Power BI dashboards and reports themselves, they don't have that same level.
When you publish a report to the service, there's three, if your subscription is premium, you can publish to a dev, test, and dev UAT and production environments. But I'll be honest, it's not a great experience. So that's our feedback from using it so far.
Yeah, there's somebody saying, I think there's still a big issue, or Tom said, a big issue with Power BI, they are commercial tools. Power BI Sentinel springs to mind that do this sort of thing, but nothing quite like Git. Also a question, how difficult is it to get execs to understand funnel plots?
Oh, that's a good question. I think if you can get the basic message across in 30 seconds, it's all right. And after that, if it's not dropped, it's probably not going to drop. If the penny's not dropped by then, it won't. Coming back on the question about commercialization, yeah, the only custom visuals we could find on them were on the market. And that's why it's been such a great contribution by my colleague here, because those visuals are now for SPC and funnel plots are available free. So you can go to the repo and download them. We'll post the link in the Zoom chat shortly. Yeah.
There are a couple of thanks for using and mentioning people's packages. It sounds funny, doesn't it? But yes, this is so wonderful that you've come here having used a few of those, and I'm sure we're desperate to see what you also do. But somebody's also then also sorry,
we wouldn't have got this far without all the help, so we appreciate it.
Well, it's wonderful to hear, and it's so, I mean, I'm just going to jump in and say it's wonderful to hear that we're not just alone in tackling the same issues. The whole world appears to be doing it too with quality improvement. But somebody has asked, which I think is also quite pertinent, they're looking to do some QI work specifically in radiotherapy. I suppose it's any suggestions to anybody. How do you get started? Where do you go?
Yeah, that's a good question. I'm not too sure that I'm best placed to answer that. We're doing a big piece of work here around MDT software in WA, but it's not specific to radiotherapy. Sorry, I'll go away and think about that one, but I haven't got anything major. So maybe I'll just direct message you afterwards. Sorry, nothing's coming to mind. So.
And then maybe just generally, rather than just specifically for a particular speciality, how do you get started?
Well, that's probably a question we can answer, is that there was this big question at the start about how pure do you want to be? And I think particularly when you're introducing SPC or funnel plots to an audience that hasn't heard them before, I think simpler is better. We always had that vision in our mind that after a year or two, we would go down a slightly more complicated route. And we've definitely got some staff who are just really enthusiastic and criticizing us for not using the right type of SPC, which is great. That's a good place for us to be in. But I don't think we'd have carried the majority with us if we'd gone for something really complicated from the start.
Yeah, definitely. Coming from a statistical background, there's always the temptation to do everything perfectly and everything technically correct. But when it's about increasing uptake and accessibility, sometimes good is good enough.
And if you're not already done so, and other people watching, we have an NHSR Slack group, which people are welcome to continue this conversation, connect with each other there, as well as through email. I'll thank you for answering those questions. Thank you for popping some things into the chat. I just wanted to say thank you, of course, for such a great opening talk and for lightening up our morning. I mean, it's quite light here in Nottingham, but those pictures of the quokka, they just brighten your day, don't they? Never mind having Deming in your office. I think you should have more quokka. You probably do have. There are a few more talks later as well about using SPCs and run charts. So I'd like to encourage people to stay tuned or catch up later for those. And our next talk is, I can see Sarah's ready to wait to come in. Just to extend thank you again, Rich and Andrew, that's wonderful. And Sarah Culkin will next be talking. She's head of analytics of NHSX, talking about another subject very close to mine, and I'm sure many other people's hearts who are here, free and open. What is the role of the centre? So over to you, Sarah.
Thank you very much. I'm check that you can
yes,
hear me all right.
I can see it as the full screen.
And the screen is coming through. Excellent, great. Hello, lovely to be here. So thank you, Zoe. As Zoe said, I'm the head of analytics and data science in NHSX. And so my talk is, and I promised it will be, about the role of the centre when it comes to free and open. But I thought it might be useful just to start to set a bit of context about what exactly NHSX is, because this is often a question that I get. So NHSX is a joint unit set up probably about 2.5 years ago now between NHS England and Improvement and the Department of Health and Social Care, but it does actually sit within NHS England within the Transformation Directorate. And its role is essentially to support the digitisation, the connection and the transformation of digital products across the NHS. So everything that we do, we try to sort of see within those three barrels of either digitizing, connecting, or transforming, and sort of the process flows from one to the other. I'm not going to talk you through all of these in great detail, but this just gives you the sort of things that we are prioritised, and they involve, as you would expect, things like frontline digitisation, the data architecture, and we also have a focus on the skills in the workforce and social care. And some of the things we've achieved are also just flashed up there. I say I didn't personally have much of a hand in any of these things other than providing a fair amount of data and analytical support behind the scene with my team. But it does kind of provide actually quite a nice framework for how data is used in health and care. And the way that I actually see data being used well actually also sits in the three buckets that the NHSX has used. And so I see underneath any kind of digital transformation attempt, really at the foundation, you need to be able to, in the digitized bucket, you need to be able to collect and actually collect that data. And then the connect bucket, you need to be able to flow the data. And in the transform bucket, you actually need to do good analytics on it. And I would actually argue that good use of data and analytics is at the heart and the core of digital transformation. And so that brings me on to the unit that I am at the head of. There's about probably 20 of us now. We're a team of analysts, statisticians, economists, data engineers, etc. And we have three roles. The first role is, I suspect, the role that most analytics teams have out in a trust, in an ICS, within NHS England, and that is to support the programme or team or area that they work in. And so we have one team which is dedicated to, as you would expect, all the kind of analytical support requirements NHSX needs, be it dashboards, be it economic appraisals, be it help with surveys. You name it, I'm sure you can guess what these kind of things involve. But actually, because, as I've said, the good use of data and analytics is really at the core of digital transformation, we also have a role in the kind of wider policy of how analytics is used and strengthened within the sort of the broader sector. And so we have two different teams that, rather than focus on helping NHSX with their specific analytical challenges, their dashboards and their data needs, are actually really focused on facilitating good use of data and analytics actually out in the wider sector. So there's an analytics as a profession team led by Sarah Blundell, who, and the aim here is, as the name suggests, it's about really professionalising analytics and data science and data engineers more broadly, giving the structure to the profession that will really allow it to go from strength to strength. And I can talk about that a little bit later. And then the second section, the second area, which is probably more relevant to and of interest to the NHS-R community, is we have an innovative analytics branch led by our lead data scientist, Johnny Pearson. Many of you may have come across before. And this is all about doing things, as the name suggests, more sort of blue sky research, innovative analytics, but not specifically for NHSX, but more to try to facilitate and support and champion their use more broadly by both leading by example and helping others to make the most of their data science and innovative analytics skills. And so what is the role of the centre, coming into the topic of my talk? And I would say one of the key things that the centre can do, but not the only thing, is to set the broad strategy and the direction of travel for particular areas. And so one thing that NHSX has recently delivered, which I think is of great relevance to the use of open and free technologies and approaches, is that they've recently released a data strategy. So this was published by the Department of Health and Social Care, but was put together by a team in NHSX. And in particular, we have managed to include a fair number of commitments that specifically think about how data and analytics can be used well. So if you haven't ever had a chance to look at this and you've got a spare 10 minutes, by all means do look on the Department of Health or the gov.uk website and you should be able to find it. But the things that we have included, and when I say we, this is a joint analytical team that is formed between NHSX and NHSEI, a number of commitments that we have for the analytics profession in here. I'm not going to go through this in great detail, but just touch on a few things. So for example, the first thing in 2021, that light blue colour, we want to put together, and in fact we already have behind the scenes started building an analytics hub that will be able to point analysts and data professionals who are quite new to the sector to all the different key areas and groups to really kind of make the most and understand what the landscape looks like. So for example, direct to the NHS-R community, also AphA, also the work that goes on the AnalytX platform, and the work that HE are doing around reshaping the workforce. And in 2022, we are also well underway to roll out a set of competency frameworks for data engineers, data analysts, data scientists, etc. And we also have established a developing data and analysis as a profession board, which is in an ongoing way. We look to agree frameworks, guidelines and policies to operate in and help to build ecosystems. And then that sort of big block in the middle by March 2022, a whole range of stuff, which I'm going to sort of go into around understanding the workforce better, helping to grow the AnalytX community, which sprung up in response to data and analytics requirements in COVID-19. And then there's a whole section of things there around, towards the bottom, around making new source code available, publishing it under appropriate licenses, but also to publish a digital playbook on how others could and should be doing this. And then finally, we want to, and have already started, to create partnerships between academic researchers and frontline analytical teams to really enhance the exchange of knowledge and skills. So one of the things I just wanted to touch on that kind of mentioned there is the AnalytX community and the sorts of things that are available there. I'm aware that my colleague Suki is going to be talking in great detail about AnalytX tomorrow, so I'm not going to try and repeat all of that now, but just wanted to draw your attention to, within there's a whole load of pages that are set out like this, and in particularly within the community network and learning area, there is a vast amount of information and free training. So in particular, there's software training, so it's set out by different types of software or package or tool, and it's also set out by the type of role that you have. And in particular, there is a whole load of stuff on R. You will recognise that a great deal of this training is coming from the NHS-R community, and there's some other bits and pieces in there as well. There's also Python training and many others. So do, by all means, check it out. And we absolutely see this as a role of the centre to be able to collate and show people the sort of the offer that's out there, rather than sitting in pockets. Also just wanted to say that although we have put in commitments around sharing open code, it in fact already exists in the NHS service standard. I'm not sure, you may have been aware of this already, but I'm not sure it's necessarily sung from the rooftops as much as it can be, but it does already exist within the NHS service standard that all new source code should be made open. Another thing I wanted to sort of touch on is, as well as setting out wider strategies and supporting existing communities, sometimes it is the role of the centre to, hopefully you can still see my screen okay.
It's gone blank, but I can see a link saying NHSX Analytics Comms channel. Oh, no, back to the screen. Technical problems.
So one of the things that I think the role of the centre is to actually fill gaps where they don't exist. So, for example, the NHS-R community, a thriving, brilliant example of a community. However, there were sort of fledgling people getting more involved in Python, and we thought it would be useful and interesting to fill that gap. So members of my team have set up an NHS Python community, which you can see here is their website. The website link is at the bottom of the screen. And we have also recently, in the name of trying to do things at the centre that perhaps we're best placed to do and to lead by example, have set up our own, we're calling it like a technical storage website, but the link again is at the bottom of the screen, and it is based around GitHub. It's a GitHub.io site where we are trying to share as widely as possible both the work that we're doing, but also the guidance that we want to make available. So for example, here we have a whole load of stuff on sharing code in the open and open source tool requests and some thinking around that. So for example, we recently commissioned a security firm to do a piece of research into how open source tool requests and how open source tooling could and should be considered when new requests come into teams, because this is something we hear quite a lot, that actually it's you know, the hardest thing about using any kind of open source tool is to actually get your IT department to install it for you. So a whole bunch of blog posts that are there based on the research that they did. And just to say that when I talk about they and we, this is by no means me doing this at all. It is in fact, this particular site has been set up by Johnny, who's there. And the Python community, for example, is really strongly led by Mary, Craig and Mattia. And Dan and Martina are also data analysts and data scientists with a strong flair for open source in the team. And so it's really thanks to them that a lot of this work gets done. As well as putting out thought pieces and guidance, we'll try and share our own work as much as possible. So there's a whole load of stuff there around projects that we've done. Again, please do take a look. And as I say, there's specific pieces around evaluating open source tools and the things that you can think about to support, for example, IT teams with these requests. So I'm really kind of getting to the end of my talk now. The only other thing I wanted to sort of touch on as something that we're doing from the centre that we really see as our role is that we've very, very recently, as part of the NHS-R solutions approach that the NHS-R community has developed, which aims to basically to fund R packages or training that can help the NHS, where a bit of extra sort of funding is required. We have recently agreed with Professor Mohammed that we will match fund the existing funding that's provided for this so that it can double its reach. And as part of this expansion, we've also agreed that people can apply for funding to develop analytical open source approaches that are not just in the R language, but in fact in any language. So for example, the Python community may also be available to apply as well. I know that there's also an NHS-R solutions talk on tomorrow morning as well. So if you want more details on that, I would suggest going along to that. But I guess in summary, where we see the centre's role is, as I sort of mentioned at the start, I think we're well positioned to set the defined strategy. But then underneath that, as well as setting the broad strategy, there is the need for and a role for us, I think, to provide a learning system and to also be a learning system. So that's kind of a dual thing here. Number one, you know, we can provide and collate resources for continuous learning, but actually ourselves be a learning system so that we see, for example, when the Analyst X community sprung up, to really, word of the moment, but pivot to really support that and to support the NHS Python community. And then the final thing, and the really big thing here, is that we really need to lead by example and really facilitate others to share and be open by default, and to try and help break down the barriers that allow people to do that. So that's really what I see our role is. I would be very, very interested to hear what you think our role should be. But I guess the flip of this is, what is the role of not the centre? And I guess there's a few things here for me. Number one is that please, we're nothing if we do not engage with the wider community, and that's a two-way thing, rather than us just perhaps putting things out in isolation. It's very much our role to understand the needs of the community. It's the role of the community to share those back, either when things are going well or where you think there's a gap or something is missing. But then the other side of things is to that and actually engage and be active members. And when something it develops, actually, please do use it, because if it's not picked up and used, then we struggle to justify our existence. And I think that's probably about all that I wanted to say, but I would be very interested in, again, comments, feedbacks and questions.
Thank you for that talk. There are a couple of things that came through. Two comments were about links. I think everybody was really excited, as I was, like, oh, we need some links. I saw there was a GitHub repository, and maybe some of that could be, if it's there already, just directing people. That would be fantastic. And another comment, or question, actually, this is a question, sorry. What's your take on the balance between data science embedded in the NHS and commercial data science / machine learning?
So is the question embedded data science versus commercial data science, or more machine learning versus other types of data science?
I'm not sure.
I take it.
Data science is the answer. Data science. I mean, for me, it's a bit like, what is data scientist? But you're talking to a philosopher now who just asks what is all the time. So I suppose that is, what is data science for me, and how does that differ from commercial, and how do we get commercial in, and are we going to be commercial or going to be different? That's my take on it, though.
I personally think that good data, the old Venn diagram that gets bandied around for data science a lot is the whole computing, analytical skills and domain knowledge, and it's that bottom one, domain knowledge, that is really key for me. And I personally think that it's teams and data scientists and analysts that are actually based within the NHS and within the healthcare sectors, it's not just the NHS, that really have that domain knowledge to know their policy area, to know their their patients, know their demograph, know their data. And so I personally think that the best set up data scientists are actually those within the walls of the healthcare sector, and therefore I would suggest that it is a better investment to strengthen their profession and their skills and their visibility than necessarily to go down the commercial route. But that's a personal view.
Yes, well, that kind of fits the openness that we want to work towards, I think. So I'll wrap this up because we've got about a minute, and then I've got to introduce the next person. So thank you so much for what a wonderful talk. And thank you also for mentioning the solutions with the NHS-R training. There will be a talk tomorrow morning from Gary about some of the solutions that we've done. But don't forget, this is a community, both the R part and Python. It's NHS-R plus NHS plus R. So if you have a solution or an idea, definitely tune in tomorrow to see if you can, what we've done, what we can do. Because when we talk about training, it's not just about receiving training, it's also about delivering it too. So I've myself been delivering some of the training. So thank you for mentioning that, and thank you for joining us together, because we're not separate from the Python people, we're not separate from other analysts who use SQL. This is a big community, and we have big hearts. We want people all to come along and contribute. So on that, people are keeping to time really well. I would like to introduce the next person, which is Rony Arafin. Hello, welcome. Rony is the Chief Operating Officer of AphA, which is the Association of Professional Healthcare Analysts. Trips off the tongue. And he's today going to be talking about empowering analytics using open source tools. And yay, welcome. And the floor's yours.
Thank you very much, Zoe. Thank you. I'm delighted to be here. Thank you very much for inviting me. I must apologize in advance because I've got a bit of a cold, so do apologize for my croaky voice. So I will try and share my screen, hopefully.
Yes, I can see it. Thank you. Yeah.
Okay, brilliant. Thanks, Zoe. So I will start. So I wanted to talk to you today about empowering analytics using open source tool. And a lot of the things that Sarah Culkin have mentioned flows quite nicely to what I'm going to talk to you about. So I'm not going to focus on, as the title suggests perhaps, on using a particular open source tools, but more I would like to talk about, how we can think about the things that influences our behaviors and our thinking processes in terms of using open source tools. So let me just click on the next slide. So what I'm thinking and what I wanted to kind of talk to you about is what really sits behind our thinking process when we think about how do we use analytics to use it to its optimum capacity, if you like. So what are the factors that influences that our choices and behaviors? So I think there's something around the culture and something also around the workforce, around our capacity and capability. So it's really interesting that what really influences our hearts and minds when we think about using analytics and really delving into the arena of using open source tools. So if I talk to you a little bit more about the culture, so I think that's quite an important part about how do we choose to utilize something, be it a tool or a change in an organization. So in terms of data and analytics, some of these things that I will say to you in the slides is what we experience here and now. So you live and breathe in the systems that what I'm going to talk about. So we see quite a lot of organizations, whatever types of organizations it is, we tend to draw into big, expensive commercial tools. Now, I'm not saying they're bad or good or anything else. What I'm saying to you is that there is a disparity. There is that kind of lack of equality amongst lots of different organizations. For example, one acute trust, a big acute trust might be able to pay for a big proprietary software, but in the same system, a small social care organization who may be able to contribute a lot of really, really good intelligence, not going to be able to utilize that tool because they are not able to financially invest in that. So by doing that, we are not really integrating as a system or as a data and analytics community properly. So we're not really sharing, and we still, as the picture suggests, we are being very protective of our boundary. And we would like to just do things in our own ways and share our good stories in our own cells or in our own spaces, but not being able to really reach out and share that with the wider health and care system. The other thing around that is information governance. I'm sure when we talk about it quite a lot, we tend to also avoid it quite a lot. But we tend to utilize that as an excuse that actually things can't be done. Or, as human nature, whenever something is difficult to talk about, we leave it to a side and we take the easy option and try and get on with something that we can do on our own or do it quickly. But actually, we could utilize information governance to our advantage to work together, work in data and analytics, utilize open source platforms and methods to reach out to other people. And the last thing for me really fascinates me because we are talking more and more about integrated care system. We are all in it now. We are thinking about how things are shaping, and it's very, very good that people are coming together to deliver a purpose, the purpose that we work in the health and care system sometime, to improve people's experience, people improve the quality and safety of people's care. So why don't we think about integrated analytics? It is now time for us to really think in that way. That when we are thinking about integrated analytics, I think open source becomes a core part of that discussion, rather than being binded into something that you can't share with other people. And so the challenge we have is that we're coming from a lot of historic baggage, but actually we have got the platform and we have got the opportunity to be able to come together and make something really good happen. The other part of this is around workforce. So our capacity, our capability. We are all seriously busy, all of us, and there's no doubt about that. But actually, this is probably a common thing that anybody asks us to do something or look at something or, you know, pursue something different, learning and development, trying something new. We say we don't have time because that's the easy option, as I said before, the human behavior of taking just this small, just a quicker option. So how can we turn that around? I invite all of you listening here, and I know that I'm talking to the people who are already in this space, and I'm talking to the people who you're already signed up to this. But actually, if we all in here take individual responsibility, we will be able to make a difference, I think. So we also need to think about professionalization of the data and analytics. And I'll talk to you about that a bit more around what AphA and we are trying to do and we are doing with our partners. But actually, is a lot of it also boils down to how do we really tell people that as a scientific professional, we are giving our opinion and that opinion needs to count. So it is not about networking. I'm talking about, you know, intensive data and in this space of digital, a lot of people, as you will probably relate to if you work in data and analytics, you go into a meeting and you'll be asked to fix the projector. It is not around that. It's actually around that we are a scientific professional and what we're giving you is a fantastic intelligence for you to be able to deliver better healthcare. So we need to really operate in that capacity, in that space as a scientific professional. So we do need to take individual responsibility to be able to, you know, walk and talk in that space in that same way. So that's why I think sometimes it comes to our mind, we just don't have the time. But I invite you to think that actually what the future holds and how we could better utilize our time to make a difference. So this is really, you know, follows on from what I talked about. So we do need to be able to, which is tough, think about crossing the boundary and get ourselves into a space that we can explore more. So when we talk to an organization about let's use an open source tool, it is like a crossing a boundary because we hold that historic baggage and we want to keep to what we think is safe. But actually, it's not about being safe. It's not even about being courageous and trying something. It's about making a difference to the way we work and utilizing the best of what's available. So the question is, are we ready? And are you ready? And I think we are, because there are a lot of opportunities that's going on in this space now. There are, you'll be aware of, and I'll touch on some of this, some of the things. There are opportunities here and now. There are opportunities coming up in this landscape, which is fascinating. So Sarah talked about, I'm really pleased actually that the data strategy, NHSX data strategy. So if you haven't looked at it, please, I'll ask you to look at the summary version. If you look at AphA website, or if you can look at the link itself, there are lots of information, but particularly the commitment of developing how to code open source for health and social care organization with, you know, delivering guidance, gives that kind of concrete base to go back in our organization. And as individuals, we can say, look, things are changing. There are national guidance available. There are things that's happening in this space, and we really need to consider open source and being able to share and learn and work together as an integrated healthcare system. So there are some other things that's happening, and I would invite your involvement, please. So we are working with, AphA is working with NHSX to deliver a national competency framework, and NHSE and I are also a key partner for this piece of work. So the analysts, they don't have a competency framework at the moment. So we are trying to develop a baseline for anybody interested in data analytics and what that kind of holds. So we are developing a alpha stage with some of the test and pilot sites. If you're interested, you can find out more information on AphA website. And of course, to end the point, so we are offering the professional registration. under the Federation of Informatics Professionals, the FedIP family. So you can already now apply to be a professional registered analyst, and you can have that to your name. So you can be very proud to wave the flag of being an analyst and being very proud to be an analyst. And Zoe has very kindly introduced me. So the wonderful Zoe in AphA, she's holding a group called Data Ethics. So this is an open forum to discuss about, what we think, our thoughts and our ideas. And I would again encourage you to join in that conversation, please. Because actually, by having more dialogue, by having more of these conversations, we are able to really influence the landscape. We're able to make a difference. And that's what we need to do as an analytical community. So I talked about AphA, and you might ask, why AphA? So AphA was, in its infancy, a concept organization to bring in and represent the voice of health and care analysts. So we are doing more and more of that. We are really delighted to be a professional body representing all of the health and care analysts in this sector. So we would like to work with our partners, everyone in this data analytics space, and actually voice the concerns of health and care analysts. For example, using the open source tools. We know there are massive advantages. There are phenomenal advantages for the organization, for the analyst, and also for the people who are receiving care in health and social care. So for all of those reasons, we will carry on talking about this, carry on endorsing and supporting this idea of using open source tools. And this is why we're delighted to work with NHSR and the work that all of you are doing as part of NHSR. Absolutely fantastic to make a difference in terms of sharing and learning from each other. So AphA's really moved on in terms of working with collaborative partners. And as I said before, NHSR is one of our really key partners. So we want to have those regular conversations with people in this space as a professional body, and also representing the voice of the health and care analyst to shape the decisions that's happening in this space. So I know there's lots of things going on, and lots of things are really, really good, but we are trying to play our part to join in and influence those discussions. So we've set up an advisory committee. You're more than welcome to be a part of it if you're interested, to know what's going on and being able to really have that conversation dialogue to shape things as it's happening. So this is kind of my last slide. I wanted to talk a little bit more. I wouldn't bore you to death with a lot more other slides, but from what I've said at the beginning, and if you follow kind of that storyline that I'm talking about approaching something new, really giving ourselves that time and space to think about, are we ready? Are we prepared to make a difference? And I think we are. So is this a revolution? I think sometimes it feels like a revolution, but obviously it isn't. I think it's more appropriate to call it a real evolution stage that we're going through in this space, about embedding that thinking process, changing our hearts and minds around using open source tools, and how we can work collaboratively together and not really hold our piece of code, our piece of report, our piece of SQL script or our script as this is just mine, but really sharing and helping and be open to receiving feedback and sharing it for the wider good of other organizations. They don't have capacity to invest loads of money, but really doing fantastic work in the third sector, in the social care sector, and help them to deliver better service. So really work together as an integrated analytical community to be able to open up these opportunities to improve people's lives. And that's what the journey is about. And that's what I think the empowering analytics using open source tools is really allows us to have that open discussion, open dialogue. And, all of these things you could discuss in your PDR reviews, in your team meetings. I invite you to really think about how, as individually, you can take this agenda to your team, your organization. And only that way we can make things happen. Only by your involvement, we could see this landscape changing. So that's an open invite for you to think and reflect and work with us and join in our mission to enable some of these really good things that's happening. And so I'll end on that. Thank you very much for listening.
Thank you, Rony. There was one question which is a good one, I think. How does the culture play out with the adoption of data platforms such as Foundry that answer all the cultural challenges, but in a closed environment? Oh, there's another question.
Yeah, no, very good question. So a lot of those decisions, as you know, prompts our mind. Where does those decisions get made, and how can we influence those decisions about not just Foundry, other proprietary softwares? And they're not bad, you know, they are fine if they sign up to an agreement about sharing the code, sharing the logic, sharing everything else. So we need to really understand and work together as a community to build up some steps, build up some principles, build up some checkpoints that we could all sign up to, that other providers who are coming into the health and care space will knowingly sign up to those principles and deliverables. And then, you know, the product and tools that we have in Foundry, for example, we're talking about, they will all sign up to those open ways of working. I think so that's where the cultural things plays out, because we are still fond of big organization who are able to, you know, come up and share us glossy slides and tell us that they could do a lot of things, but actually we might simply lose the vision of how it's impacting the wider system, health and care as a whole.
You've also inspired our international colleagues who suggest maybe we could have an AphA. It's based in Australia, which is a lovely place to go, but maybe even, you know, breaking boundaries, going outside of our organizations, maybe we can break into the international areas. How about that?
That's
we might visit
fantastic.
As well, with things kind of getting better, hopefully.
That's absolutely fantastic, and thank you very much to colleagues from Australia. And I would encourage and invite you to join Zoe's data ethics committee. So yes. I think that would be fantastic.
But, week on Friday. Check out the AphA analyst website for details and to join. And also conference. Somebody suggests a conference in Australia too for AphA. I think that would be great. Quite expensive to get to. It's very difficult to get funding for such travel arrangements often in the NHS and local authorities, but you know, this is something we could consider. But I don't think we have any other questions. If we do have questions, there's the AphA analyst website to try and get hold of you, and also you're in the system with NHS email, so we can track you down. But I just want to say thank you. For me, you summarised what it feels like to be on the ground, how difficult and daunting it can be to break your boundaries within your organisation and also outside of it. So I'm very grateful myself for the NHS-R community and for AphA for facilitating us meeting and getting together and raising our professional profile. So thank you very much for your talk today. And thank you very much. I think we're moving on swiftly. I forgot to mention, there was a question on Mentimeter in the chat for the next talk. So if you haven't already done so, it's a very, very quick question. And I'm hoping to introduce Emma Rand, who is a senior lecturer at the Department of Biology at the University of York.
Hi, Zoe.
Hello again. And
yes.
I have done the course that she's going to talk about, and it's you can make an R package too. And this is true. So I'm really looking forward to this talk, Emma. So no pressure.
Yes.
And so the floor's yours. Thank you so much.
Thank you. I will share my screen here. Eventually.
It's sharing your whole screen.
Yeah.
Brilliant.
Let's just. Oh yes, my Zoom window's in the way. I always forget that.
Takes over, doesn't it?
Yes. Whoops. wrong button. Hi, everybody. Yeah. So yes, as Zoe said, my name is Emma Rand. I'm a senior lecturer in the Department of Biology at the University of York. And I'm going to talk to you today about you can make an R package too. Probably because I think you might be doing the best part of it, most part of it already in your data analysis work. So just before we get started, let's just have a look at the Mentimeter. Whoops. All right, hurrah. So I'm going to have at least 13 people who will be sort of the target audience here. So I wrote this talk really for people that consider themselves R users rather than R package developers, but hopefully there'll be something for you developers as well. Okay. So in this talk, I'm going to talk about why you might develop a package, when you might do it, and then a little bit about how you might do it using the DevTools approach. So just a little bit about me. I am a biologist by training, so I'm not a programmer, statistician, or software engineer. I was biologist first. I did a computational biology postgraduate degree. I do data analysis of all sorts, particularly omics data, and I'm particularly interested in reproducibility. I'm a member of R Forwards, which you might know is the R Foundation's task force on equality, diversity and inclusion in R. And I think we have a talk from Heather Turner later on today, who also works on R Forwards. I lead a project called CloudSpan, which trains researchers in omics data in the cloud, and I'm a carpentries instructor. So for those of you that don't know the carpentries, definitely worth looking into. It's a sort of benevolent cult for teaching data science to researchers. So why make a package? So the number one reason is that you want your work to be reproducible. And when I say reproducible here, I mean reproducible in the sense that it's computationally reproducible. So that if you give the same data, run the same analysis, you should get exactly the same results. And the reason you want that to be the case is because that's what good science is. And there's been lots of high profile cases of work which didn't properly reproduce. There's a very famous example in health data by Anhøj Potti, who published some results that linked gene expression to responses to chemotherapy drugs, something which would have been absolutely groundbreaking at the time. And this was unravelled by Bagley and Coombs, and it was discovered that many of the results did not reproduce at all. And some of that was down to errors to do with Excel spreadsheets and so on. And later on, it was uncovered that some of it was to do with fraud as well. So we don't want to be that person where our results don't reproduce. So that's a good reason to make a package. But the other good reason to make a package is because you don't want this to be you. So your first collaborator is yourself, and making a package is a way to help you work in a way that future you is going to appreciate. And for 5 selfish reasons to work reproducibly, I highly recommend this paper by Florian Markowitz. He's also done a very entertaining talk, which is linked there in my slides. So conventionally, we think about making a package as being something that's done by package developers, and that would be for highly generalizable analytical methods that somebody might want to package up so that somebody else could apply them to a different set of data. And those might normally be shared on CRAN, for example, the repository for R packages, or on GitHub. But I make an argument for packaging up your data analysis project. So even if you don't write a conventional package that you're ready to share with the world with analytical methods, that if you turn your own data analysis project into a package, that will help you work reproducibly. And if you're already trying to work reproducibly, you're doing almost all the work that you need to make it into a package already. and that actually turning it into a package will help you do that a little bit better. So if you're trying to work reproducibly when you do your analysis, you might have this sort of directory structure. So in this example here, I've got a project called Chaffinches. I'm using RStudio projects, which helps me keep all the files associated with one project in one place. And you might set up some kind of directory structure where you've got a folder for your R code, you've got a folder for your raw data, folder for your process data, and you maybe have some outputs and so on as well. And if you're particularly diligent, you may also have a README and have licensed your project. So if you're already doing these kinds of things for your analysis, or even if you're just producing a little bit of data, a structure in your directories, you're halfway already to be able to making an actual package. So making a package is just a short step really beyond what you're doing already. And then how to make a package, it's actually a little bit easier than you might think it is. So if you're a person that uses RStudio, then you'll find it very straightforward. And I recommend using a particular approach, which is with a package called DevTools. And DevTools is a package which makes package development in general quite easy, or more easy. And it has a lot of associated, it's now been devolved into several different packages with lots of helper functions to help you organize your data analysis and add particular files like readmes and licenses simply. So if you were doing a data analysis piece of work, you might use an RStudio project, and the way you would normally set that up would be to either use the menus here on RStudio in the top right-hand corner of the window, where you do new project, navigate somewhere that's a good place to put your data analysis project, give it a name, and then RStudio will start up in that directory, set your working directory, and you'll be ready to start your data analysis work. A shortcut for doing that, or a command line way of doing that, is to use the use this package, which is one of the DevTools family packages. And you can use create_project, and that will automatically create a new project for you as well. So that's what you do for an RStudio project. When you're making a package, you don't use the RStudio project, the create project function, but instead you can use this create package function. So you have a couple of extra limitations on what you can do, because the name here has to be a acceptable package name. So for that reason, you can't have underscores and hyphens in the name. So instead of using create project, use create package. And what will happen then, oops, wrong way, is that R will automatically generate a lot of package infrastructure for your package. So you will get an RStudio project, which is also a package. It'll have a description file, which includes metadata about the package or about your data analysis. It'll have an R directory for putting your R code. It'll have a namespace, which declares the functions you export and the external function on which your packages depend, your project depends. And all of these things encourage you to document your data analysis in a way that's going to help future you. So what goes in the metadata, in the description? Normally, this is where you would give a title for your analysis. You might say what version it is. You'd say who's contributed to it, and give a bit of a description about what that project is all about. And you might also here state under what circumstances or what licensing conditions your work can be reused, which is good practice. You also have the opportunity, if you're using a package structure instead of just a project structure, to use the DevTools document function. And this allows you to generate those HTML-like pages of help information for your functions. So in your package, if you write any function, so here I've got a very simple function here that creates the sums of squares or calculates the sums of squares. And by one of the menu options, you can insert an Roxygen skeleton. And these are Roxygen comments here. They look a little bit different from normal R comments. And you can see this is encouraging me to describe what my function parameter is. So I might add a description on here about what that actual thing is. It's a vector that's taken by this function. And you can also indicate what's returned and give examples of how it's used. Now, the nice thing about these Roxygen comments is once you've written these, which are pretty much similar to what you might write as comments in ordinary R code, you can then use this DevTools document function to generate the help files that go with your functions that you will then be able to call by using the question mark that you're used to using when you're looking up any functions in R. And also other people will be able to use your functions that way too. Another piece of useful infrastructure that you get if you've made a package is the ability to check your analysis. So of course it doesn't check whether you've made the right decisions about statistical tests or analytical methods, but it does check some of the infrastructure for you to check that it's consistent throughout the project. So it will check, for example, whether you've declared your dependencies, which is what's going to make it easier for other people to use your code later. It will check whether your package or your data analysis is licensed, which is going to determine whether people are allowed to use it or not. It will check the information in the description, whether you've actually said what your data analysis is about. And all of these are useful tools for helping encourage you to follow good practice in doing your data analysis. So in summary, you can make a package. You're probably nearly doing it anyway if you're trying to work reproducibly. It encourages and supports you to work more reproducibly and document your analyses well, not just for others to use, but really crucially for future you to use. It helps you test and check your analysis and also to distribute it if you need to. And it's made much more easy these days by the use of DevTools and its friends, and in particular, the Use This package, which will help you generate the files and folders that you need to develop your package. Okay, so that is all I'm going to say today. Thank you very much, and I'd be happy to take any questions that you might have. Shall I stop sharing my screen here?
No.
There we go.
I think everybody, oh, there was a comment, which is just to remind people that, or just to maybe promote that we have a GitHub repository in NHS-R Community, which everybody is welcome to contribute to, either existing packages or creating their own packages. And Tom has kindly set up a template for us with, say, fancy things in GitHub, like GitHub Actions and things which people may not even be aware of, but at least then it's all set up. So it's a really good way of getting involved with something that's already in existence or trying out something, and there's a lot of help, and I can definitely guarantee there's a lot of help within our community. Lots of people saying thank you so much for raising awareness about R forwards. This wasn't something that people are already aware of. There are so many great organizations around R.
Yes, there are.
A massive community.
Yeah.
And great encouragement to finally write that package. That's what we want to hear, isn't it? And somebody's asked, which is what I was going to ask, which is a fantastically great I like that. Serendipitous. How often do you create packages personally?
For my data analysis now, I nearly turn every data analysis I do into a package. Wow. So I don't distribute it, but it's for me, so that later I'll easily be able to install that data analysis package. Everything will be set up. I'll know whether I've got all my dependencies sorted out. So it just takes care a lot of the housekeeping for me.
You're so kind to future you, aren't you?
Yes, I am. I've learned the hard way.
Yeah.
Yes, past me has suffered many times.
What did I do? What did I create? That question's also sort of extended to how specialist specific do you make the package? Which kind of, I think, leads to when you're saying about your analyses.
Yeah, so when it's for me, they're mainly fairly specific to that particular data analysis project. Obviously, I have some functions which I use a lot, which I've got in another package, a little package for my own. But mainly, yeah, they're specific totally to that data analysis.
Could you say something about how this integrates with unit testing features?
Oh, yes. So if you're using DevTools, then that has a really nice set of helpers for writing test functions. Of course, it doesn't help you actually write the tests. You still have to do the difficult bit yourself, but you could automatically set up the test folders, test files for every single function that you have.
Yes, that's like a natural extension, isn't it? When you've got everything set out, the actual test bits can take as much time sometimes as the analysis itself, but they are really useful. And do you have a GitHub?
Yes, I do. So it's 3 MMA. So I'll put it in here. Oh, I've done pound instead of. Don't know my own name.
Oh, well, I misspelled my my Twitter handle in GitHub, so now I have 2 accounts because I couldn't even spell my own Twitter handle.
Yeah.
So
there we go.
It happens. How do you structure an analytics workflow as a package? For example, I assume the outputs aren't included, but the functions to generate the outputs are.
So if they're just for my packages, I would usually include the outputs as well.
Oh, so you keep them in a private repository then? Is that?
Yes, those ones would be private ones that I wouldn't put on GitHub mainly. Yeah.
And the questions are coming thick and fast, aren't they? How long have you been using R, and what was the learning curve to get to this level?
Oh, good question. I guess I've been using it for a long time, maybe 20 years in total. But like when I first started using it, it was all, native R with hardly any helper infrastructure. ggplot didn't exist. RStudio didn't exist. Yeah.
I've heard of those days. Those are days that I miss, thankfully. Oh, questions still coming through? Yes,
I agree. Package development, thanks to DevTools and use this, is fantastic.
That makes life so easy. I don't know this hardship when I've been doing this. So someone said, I've never thought of a private package. Somehow I assumed the package had to be up to CRAN standards.
Oh, no, absolutely not. You don't have to, nobody has to see your package. It's just for you.
And I guess you do this as well. You deal with semi-sensitive or even fully sensitive data. How do you deal with that with your repositories?
Either it's only backed up on a non-GitHub repository, or it's in a private repo on GitHub.
Yes, we tend to, in our team, we have our data on our network drives as the NHS, and we then link to them. We don't put any data unless it's publicly available data like ONS mortality data that is just in a different format. That's the only thing we put on. Wow, I'm going through all these questions. I wanted to know what prompted you to first create your first package. Now that was probably before the use this and the DevTools helper, but
no, it wasn't actually. I thought I would try and create a new package, and then I read I don't know if anybody's seen, what's it called? I think it might be called Writing R Extensions, might be the name of the R CRAN sort of place where it teaches you how to write packages. And I took one look at that and I thought, oh my God, no, this isn't for me.
I can imagine.
Yeah, and then I decided later on, yes, that's it there, R extensions. Somebody's just posted links. Thanks, Gary.
You said you tend to create packages for almost every analysis. I've seen some people would prefer not to have the overhead of this. I suppose it's because it's extra work.
Yeah.
But how long did it take you to get used to using this workflow? I'd also question, is it greater work?
I think it depends on it might depend on how often you have to close down one analysis, start on something else and leave it for 3 weeks before we can come back to it, to what constitutes extra work.
I think my thing is documentation.
Yes.
We need documentation, but it's always, I say always, that's a sweeping statement. Sometimes it is like the last thing to put the effort into because it takes effort.
I guess I might say that because I feel you're right, it's the thing that we always want to do last. And now we have the DevTools set of tools and packages, it's actually more fun to do.
Yes, that is true.
Yeah.
And also the connection to Git. I was doing that on my own.
Yeah, right.
Today. So with using all the use this package, there's just so many functions in there. It just makes it a dream. It's magic. It really does feel like magic. It is magic.
Yeah, absolutely.
And that's what your packages can be. They can be like your own personal
bit of magic. Yes.
Yes.
Yeah.
So I'd like to wrap up. I've kind of overrun, and I'm so sorry, but we had so many great questions, and it's still going on in the chat. We're going to go to have a break now. I'm going to come back at 11:10. I wanted to say thank you, Emma, and thank you to everybody. But Emma specifically, it was a wonderful talk to get that package creation down into such a small amount of time. It feels like, but it's not. That's the point. It feels like this is only for advanced analysts do this, and that's not true.
Yeah, absolutely.
Thank you so much. And you lived up to my expectations.
Oh,
I really left you going, oh, yeah. But it was great. And also check out Forwards. Keep in touch with the Forwards workshop. Emma and mine have also worked on some fabulous slides for presentations on creating packages, which I've used as material to work from. So
we're doing a train the trainers version of that soon, actually.
Yes. So
I'll send that to you. Yeah.
Yes. And put so the trainer, there were 30 slots, weren't they? It was advertised through MIR, which is Minorities in R as well, on Twitter. Yeah. So looking for 30 people to represent and maybe train the trainer of these if you're feeling competent, or we want to get that out there, that enthusiasm for creating packages. Please do that. Please sign up. And thank you everybody for coming. And I will see everybody back at 11:10 for another session of wonderful talks. See you all very soon. Hello and welcome back, everybody. It's 11:10 and we have our next session of day 2 at the NHS-R conference. I hope you all had a refreshing break, and just to remind everyone that this is being live streamed on YouTube as we do this, and will be available to catch up at a later date if you miss anything or if you want to just go over things again, because they're so great. Discussion and questions are actively encouraged in the chat. And after the conference, just wanted to say again that discussions can be continued in our NHS-R Slack group. And the next talk that we're going to have up is from Jacob Anhøj from the Centre of Diagnostic Investigation, Rigshospitalet, University of Copenhagen. We've gone quite international again this year with a talk, Run Forest Run, Understanding Variation Using Runs Analysis. And Jacob has kindly shared his talk in the chat, his slides, but here he is in person to talk through them. Welcome, Jacob.
Hello, Zoe. Can you hear me?
I can. I muted myself. Yes, I can hear you.
That's
but
great.
Not me.
Yes, great. Thank you for the introduction. And thank you for the help last week with our SPC workshop. Without you, we wouldn't have managed it through the day. Also, thank you to the NHS-R and to Mohammed in particular for inviting me. By the way, where do we pick up our mocks this year? If you could just leave the address in the chat, I'll be there. My name is Jacob Anhøj. Think Anhøj and then say Anhøj. It's not that difficult. I'm a physician. I live and work in Copenhagen, Denmark. And I work primarily with quality improvement in general, and in particular with surveillance of hospital infections and antibiotic resistance. My main interest is statistical process control, which, to paraphrase Don Wheeler, is not about statistics and not about control. It's a way of thinking with some tools attached. And today I'll talk about one of these tools, runs analysis, which include statistical tests for randomness in data sequences and are very useful for identifying trends and shifts in data over time, which is what we are really looking for when we are trying to improve healthcare. Now I'll share my screen. Just a sec. Can you see my screen?
Yes, I can see. Yes, it's all shared.
Great. Now, things vary. Here you see 4 processes, 4 graphs representing 4 very different processes. If you look closely, you will see that, that these processes seem to have about the same center and about the same range. In fact, these 4 graphs contain exactly the same data values. The mean and the standard deviation, the median, everything in these data sets are the same, except the order in which data comes out of these processes. And this is an example of how numbers can be the same, even if they are produced by very different processes. And the other way around, if you look at the first, this is Y1, this graph, this is an example of a purely random process. These are just random numbers I have produced in R and plotted over time or in sequence. And this is an example of different numbers that come from the same process. So even if numbers are different, they may come from similar processes, or even if numbers are similar, they might come from very different processes. And this is what statistical process control is all about, to make this distinction of when are processes producing numbers similar or when are they different. I guess most of you know the run chart. It's a highly overlooked, very powerful statistical tool for making this distinction between random and non-random variation in data over time. The run chart is a simple, not meaning primitive, but a simple line graph, point and line graph. You have the time on the x-axis, the time or the sequence of the numbers coming out, and the numbers which usually represent some time of quality indicator. In healthcare, it could be anything: waiting times, mortality. In this case, it's post-op mortality from a rural hospital in Denmark. And this is simply the number of patients who die after surgery each month. But it could be anything. It could be patient satisfaction. It could be hospital infections or antibiotic use or whatever. You have to put in your own example. But if we plot these data in sequence over time, and then add a center line, which in the run chart is usually made by the median of all the data points, then you have a run chart. And if this process we are looking at behaves randomly, if these data come up out of a random process, we would say that there are no differences, there are no important differences between individual data points. This data point and this data point, they come out of the same process, and nothing has really changed in this period. If you look at data in a run chart, you can use the center line as a kind of test for randomness. If this process is random, the chance of the next data point coming out of the process being above the center line will be 50%, and the same for it being below the center line, 50%. So there's a 50-50 chance of being on either side of the center line. Now I guess you can see where we're heading. This is a kind of like a coin tossing game. On the other hand, if the process starts to change, to move in one or the other direction, certain patterns will appear in data that we could look for in our search for types of non-random variation. Again, if you toss a coin 10 times in a row, you would expect to have some heads and some tails. But if you got heads all 10 times, you would wonder what's going on here. That would not be a result of a natural, a random process. So long runs, as we call them, of identical values on the same side of the, by identical, I mean they are on the same side of the center line, is one of the signals we would be looking for to identify non-random variation. And as an effect of the process moving away from the center line, we would expect to see the graphs stopping to cross the center line as much as expected. So these are the basic ideas of runs analysis. We would look for unusually long runs of data points on the same side of the center line, or unusually few runs, and I say or crossings. Crossings is a lot easier to count. A crossing is when two data points are on opposite side of the center line, and it's a lot easier to count crossings than it is to count runs. In fact, crossings are by definition one less than the number of runs. So we should look for long runs or few crossings. We could also look for unusually many runs, and some include looking for long trends, a trend being defined as a run of data points that are all either bigger or smaller than the previous data point. So these four principles have been employed in different sets of rules for testing for non-random behavior in time series data. And the papers referenced here are to my knowledge, the only peer-reviewed articles on runs analysis in healthcare. At least that's what I've been able to find. And it's interesting because these rules, they are quite different, and they have very different diagnostic properties, as you'll see in a moment. Here's an example of non-random variation. You don't have to be a statistician to see that this process is not purely random. It starts with a gradual decrease, which is in this case is a good thing. Gradual decrease, and then it seems to stabilize at a completely new level. And here we have a long run, an unusually long run, which we would not expect to see if this process had been purely random. There are 1, 2, 3, 4, 5, 6, 7, 8. There are 9 data points in this run. That would be unusual. And the graph crosses the center line only 1, 2, 3, 4, 5 times. That is unusual for a random process that the graph only crosses 5 times. So this is an example of how runs analysis can be used to document changes, and in this case, improvements in healthcare. Now, you might ask, what are the limits for unusually long runs or unusually few crossings or many crossings or trends and so on? And here I have tried to compare the limits proposed by Carey, Perla, and myself. And you should be aware that especially the too few crossings and the too many crossings, the distribution of crossings depend very much on the number of data points you have in your chart. So this is an example with 24 data points in a chart. That could be 2 years of monthly data or nearly half a year of weekly data. According to Carey, which published this paper in 2002, and has written a very good book about statistical process control, a too long run is a run of 8 or more data points on the same side of the center line. Perla published some very popular rules in 2011, and as far as I'm concerned, these rules are promoted by the NHS and the Institute for Healthcare Improvement, and have been used in many settings all around the world. According to Perla, a run is too long as a signal if it is 6 or more data points in a row on the same side of the center line. And according to my suggestion, you should look for runs that are at least 9 data points long. Likewise, with the crossings, the limits differ a bit, not that much. And then we come to the trend rule. Carey suggests a trend is 6 or more data points in a row going up or down. And Perla loosens that to you only need 5 data points in a row going up or down to signal a trend in data. I don't use these 2 rules for very good reasons. You can read why. Actually, they are not that useful. So I will focus on the long runs and the few crossings. So why do we have so very different cutoff values for runs analysis? One should think that this would be quite simple, but it's not. And for this purpose, I have made this little game. It's an app. It's made with Flex dashboard and the Shiny engine. And I made it for you so you can get accustomed to how random data actually behave in the wild. By default, you get a standardized run chart. That's a run chart with a center line of 0, and then 16 random numbers plotted in sequence. And you can repeat that. These numbers are purely random. And if you are really into runs analysis, I suggest you do this for at least 10 minutes every day for at least a year. And when you're done, your eyes will be calibrated to recognize random variation whenever it occurs. Below here, you have a summary of the parameters of this run chart. The longest run is in this case 4 data points in a row. That would be around here and also here. The longest trend is 5 data points going up, and the number of crossings is 7. Over here in the lower right corner, you can see whether this run chart triggered one of the rule sets, and you can see it triggered the Perla rules, and that is the long trend of 5 data points in a run going up. Remember, these are random data. There's nothing special about these, but you will sometimes you will have false signals, false alarms in your data, even if they are purely random. And we can continue doing this for the rest of the day if we want to. And you could look down here and see how often do these rules make false alarms. We could also introduce a shift in data. Say improvement has happened and we move this data one standard deviation upwards. And now you will see all three sets of rules have identified this as a signal of non-random behavior in data. And you can also see that the runs tend to be longer and the number of crossings tend to become fewer. When you get tired of pressing the go button, you could ask for a number, in this case, 1,000 simulations, and you will have a summary of all 1,000 run charts with the distribution of longest runs in these 1,000 iterations and the distribution of longest trends and number of crossings. So this is useful when you are going to, if you're going to develop your own rules, you can see how often are runs actually longer than 6, 7, or 8 data points in a row. Here we have 5, 6, 7. You can see here that a run of 6 or more data points in a row is actually about 10-15%, happens about 10 to 15% of the times, even if the process is purely random. And especially the trend rule that signals in case of just 5 data points in a row going in the same direction is very active. I would say it's hyperactive. And the result is that the false positive proportion of these 3 sets of rules differ significantly. Especially the Perler rules, they have a false signal in about 1/3 of the run charts we are creating. And if we increase the number of data points in our sequence, you'll see that it's over 40% of the Perler rules, and maybe I should say the NHS run chart rules that have false signals, which in my view invalidates the use of these rules, unless you are interested in being very certain to pick up any signal in data and you're not at all worried about investigating for assignable causes for non-random variation, even if there are none. So this is it's online. You can play around with it, and the link is in my presentation. With this, you should be able to define or design your own rules for runs analysis. There are no runs analysis cannot be used to prove anything in healthcare, whether there are random or non-random variation in your processes, but it can be used to suggest when it's worthwhile to look for a cause of non-random variation. If you want to have control limits on this, you could add them here, and if any of your charts, any of your data points fall outside the control limits, it will be very visible. Also, please note that control charts with control limits are very ineffective in picking up small shifts in data that are picked up by the runs analysis. And that's important for me to say, that it's a common misconception that control charts are better than run charts. That is not the case. Run charts are better than control charts at picking up minor to moderate persistent shifts in data. Control charts are very good at picking up large, possibly transient shifts in data. So that was a short introduction. You have a link to the simulator here. You can play around with it. And now my talk is about to end. Here
1 minute. Sorry, Jacob.
Yeah, 1 minute. Yeah. Here's a bare bone function you could use for doing your own runs analysis. The parameter y is a vector of numbers that you want to analyze. And if you want to know more about this, more about how to investigate the properties of different rule sets, here are some suggested readings for you. So in summary, things vary. Even if numbers are the same, they may not come from similar processes, and vice versa. Even if numbers are different, they may come from the same process. Grunt analysis is a set of tests that are useful for making this distinction between random and non-random variation. And I would say that some rules are helpful, some are insignificant, and some are even harmful, depending on your purpose. So choose wisely. Thank you.
Thank you so much, Jakob. There's some interesting technical questions within the chat, which we can't cover because we have to move on to the other talks, but I've copied them down and I'm going to put them into our NHSR Slack group as well, so that in the channel related to the conference, so we can pick those up. And there's also going to be an informal chat, which you can come to, question and answers later, which we've just set up because we like to do this as the NHS-R community and get together between 2 and 3 p.m. GMT time, if anybody would like to continue these conversations. So thank you so much, Jakob. It spurred lots of interest and we've been sharing your links widely. The next talk we have is Peter Higgins, Professor of Gastroenterology, University of Michigan. Welcome. And you're going to be introducing the medical data teaching package. Thank you so much for coming.
Thank you, Zoe, and thank you for inviting me for this lightning talk. I want to introduce myself. I teach R to clinicians. For those of you not familiar with University of Michigan, we are the state with many, many lakes, and I teach at a large public research university. And I would basically develop this package in order to help my teaching to clinicians who are new to R and interested in analyzing medical data. And I think it's important to talk about why having a medical data package for teaching. Learners find relevant examples motivating. These data sets illustrate data challenges that they may face in their own data. There are a few medical data sets here and there in our packages, but they're fairly widely scattered, and many data sets are poorly documented and fairly hard to understand where the numbers came from or what the units are. And they're quite bare bones. It's really convenient to have a group of data sets wrapped in one package. It's easier for students, especially beginners, and for instructors. And you can reuse data sets across teaching concepts. And the medical data package is focused on patient-level research data, which I think complements the system-level data in NHR datasets package.
Oh, Peter,
and
sorry, are you sharing your slides?
I'm sorry.
No, we weren't. Somebody just pointed out, sorry.
I was running right with it, and
sorry about that. Yes,
not a problem.
And I didn't mean to interrupt either, but I just thought those slides might be useful.
They would be really useful.
Yeah,
so
but we know now that you're very early over in Michigan, so
yes.
Well, thank you for coming so early.
Now, do you have?
Yeah, it's starting to share, but it's on the slide deck show.
Okay.
Wonderful. Thank you.
So you'll have to let me know. Am I sharing properly now?
It's got the small version with the next slide. It seems to be very small. Are you on a big screen?
Yes, let me switch how I share. Sorry about that.
Technical problems, it's fine.
Stop sharing.
That's actually quite clear there, if that's okay.
Is that manageable?
Old school? Yes, I think so.
Yeah, let's go with that then.
Okay, thank you.
All right, so for those of you unfamiliar, Michigan is the state with the many lakes, and I teach at a large public research university. So why a medical data package for teaching? To have relevant examples, particularly for my clinician learners. These data sets illustrate data challenges they may actually face. And the current medical data sets in our packages tend to be widely scattered, poorly documented, and hard to understand because they're a bit bare bones and lacking in details. And it's really convenient to have the data sets wrapped in one package for students and for instructors. And you can reuse data sets across teaching concepts. And I intend medical data to be focused on patient-level research data and particularly clinical trials, which complements the system-level data in NHR datasets package. And I think the two do very complementary things. So medical data contains 15, for now, medical data sets. And this is a screenshot from the package down website. And the code itself can be found on GitHub at my page in medical data. And essentially, this was initially developed so that I could teach and build as a complement to a very slowly being built ebook on doing medical research with R. And it contains 2 historical reconstructions of data sets, which probably in the UK you're very familiar with. The 1747 scurvy trial on the HMS Salisbury by James Lynn, considered the first recorded clinical trial, and the first modern clinical trial, the 1948 MRC streptomycin for tuberculosis trial. And both of those were reconstructed from the manuscripts. I can't claim they're completely accurate, but they do allow you to remake the tables as described. There are 5 other randomized controlled trials, several which I was involved in, so I had access to the data. 6 cohort and case control studies that were donated from various sources, and a couple of pharmacokinetic studies that are familiar to our users. What I think is the most powerful part of this package is the detailed documentation. And for each data set, there is a description document and a code book with definitions and details in each variable, units, range, and levels, some background in each study, how it was done, where it was done, what they were trying to answer as a question, description of the study design, intervention, and measurements, specification of study outcomes, and some suggestions for uses of each data set, and full help files. So if you're in the R console and you type help and the data set name, you'll get essentially the same description document. And linked code books and description documents here on the package down website and on the README. The package down website can be found here. Gives you an overview as well as reference to each data set. And so now that I've given you an overview, I'm going to take a page from the Buy Nothing movement, which is popular in the US, which provides asks and plans. I don't know if it's made to the UK yet, and one give. So these are for adding examples, donating data sets, and future plans. And feel free to drop issues or direct message me on Twitter. Any way to kind of discuss if you have data or have ideas that would be potentially add to the package. My first ask is for folks to try it out, to use medical data for teaching. And if you come up with interesting examples that your learners find helpful, share them with me, either as issues or through DMs. I've had a couple of suggestions using the Strep TB data set to teach table construction with GT summary. Just attach the code and reprints. I would like to turn your examples into vignettes. And one example, Avishai Tsur, a medical resident in Israel, did this on his blog. And I am in the process of turning his blog post into a durable vignette for this package. So feel free to take a shot at it and let me know if you find this useful. I would be happy to take your examples and make them into vignettes. The second ask is if you have access, donate data sets. If you have access to data from randomized clinical trials, cohort studies, or case control studies that are reasonable size and are anonymized, this is critical. Fake names and fake study IDs are helpful. And a reasonable level of documentation or code book or a publication that I can extract detailed documentation from would be super helpful. And my future plan, and this is after adding some standard data sets, I'm hoping in my next iteration to add some untidy medical data sets, wide medical data that need pivot longer, untidy medical data that need help from tidyr, color-coded medical data, which is quite unfortunate, that need tidyxl, using unheader and unpivoter. And feel free to donate some untidy messes or examples. I may not use them as written, but an example of what kind of message, as Hadley Wickham likes to put it, all untidy data sets are different. So more examples are probably helpful. And that's something I'm hoping to do for the July 2022 release. And I also have one give. I have a bunch of medical data hex stickers. If you would like some for yourself or for learners, send me a direct message on Twitter, include your snail mail address. I have US international postage. So as long as you're in one of the 180 allowed countries, which seems to largely correlate with FIFA membership, send me your snail mail address and I will send those out. Give me an idea of how many you'll need if you have a lot of learners, and I'll send those along. This is available on CRAN as of 16 August. You can install packages. I'm planning for updates every 6 months. The next one, probably in January, will include some of Frank Harrell's data sets. And thank you for feedback and GitHub issues or any suggestions. The slides are on speaker deck. And thank you very much. Please ask questions or provide feedback in the chat.
Thank you so much, Peter, and sorry for that technical problem at the beginning. But thank you. There were just lots of interested comments, I think, and seeing it being used, the NHS-R datasets package being used in the USA, referred to. So that's amazing. Thank you. And just not to underestimate the value of having our domain medical data of various degrees and the untidy data. That's fantastic to encourage anybody to do their collaboration or contribution to that, because I'm sure we have great examples within our system. So thank you so much. Lots of people just saying thank you for sharing your great work. It was a short amount of time, but you're on GitHub and you're available around. And are you on our NHSR Slack group as well?
I'm a slow uptake with Slack, but I'd like to join.
Oh, wonderful. Well, that's the intention. So that's what we want. So thank you for your time. We're going to have to move swiftly on, but there's still things in the chat, so people can probably catch you there. Thanks for coming so early in your day. The next talk we've got is from Lluís Revilla Sancho, Bioinformatician, on a talk, Improving Analysis Process and Developing Packages. I hope you're there.
Yeah, hi, everyone.
Hello. Can't see you at the moment. Or if you're going to just share your screen.
I will directly share my screen.
It's all coming together. I can see your screen. Thank you.
Oh, great. So I will present about improving analysis process and developing packages. It's like a complementary talk to Emma's great talk a little while ago. And I'm a bioinformatician, finishing my PhD in Barcelona at a hospital clinic. And I've developed several packages from mathematical theories to designing experiments or annotation of genes. So I have some experience with packages. I want to share my experience developing those packages on this context with you. And I hope you find them useful. First, I will go to a bit of background about packages and science. Then we will leave a little bit about practical recommendations, not technical recommendations, but how to work around packages and organizations. And then we will step back to see the bigger picture of why or how much relevant are packages on the wide context of science. So to improve process, it's the thing that we have done for so many years from humanity. So from the very early times when we did the process, we find something useful, we create a tool to repeat that process, so an axe or something like that. And then with information, we do the same. So we have templates, forms that we fill out to organize. And then with software, it's the same. So we share some repeated logic so that the analyses are easy to understand or repeat and repeatable. And this is the kind of the process we always do. We simplify by making it easier to repeat actions. And that's one of the main goals of packages. But what about science? According to Wikipedia, science is the systematic enterprise that builds and organizes knowledge in the form of testable explanation and predictions. So we have our knowledge, and we have also to test explanation and predictions. The knowledge is usually the data we have, and then the testable explanation and prediction is the logic that we test and use on our analysis. And as already shared, we can have the same data, the same knowledge, and run different analyses or the same analysis, and then it's reproducible. But we like to have generalizable knowledge that it's shareable between different hospitals, different centers, different studies with different data, different analyses. So that's the real goal of the science. And packages help to make this analysis. So when we make analysis, we usually share our code or use code in a script, in a file that we write everything down there to make it easier to understand for us. And sometimes it's more or less well So we can have several scripts and we call one from another. And we might use functions so that when we repeat something like 3 times or more, we create a function so that it's repeatable and we can run again and again the same analysis on our machine. And this is very useful, and it's important to do and run scripts, especially if we follow best practices like choosing a style and recording dependencies to be able to run again the same analysis several years later, comment the code. And it's important also to find help on our institutions, like here, the community, or AphA, research software engineer, or other organizations that might be able to help us to make better scripts and also to make better packages. Packages are just a structure to run this code in a systematic way and to share it. And it has 3 main folders. The R folder with what would be the scripts that hold all the functions, and then the manual folder with all the documentation. This is one of the best folders, I think, of the packages, because years later, when you come back to these packages, you don't remember what was supposed to be. And then you can just check the documentation that you used, that you wrote, and be up to speed. There's also the test folder to check that everything that you have done also still runs the same way. Maybe there has been an update on one of your dependencies or some change on our code, and then you can run this test to see if it still holds. And then there are other files and folders that one can use. But this is for another workshop or other talks. And this is for all packages, but there are like different kind of packages, internal packages, and the more widely known packages on CRAN. And these are the open source packages that are usually focused on an abstract problem like plotting or implementing a grammar of graphics. It's a task-specific package, but it's quite abstract sometimes. And then we usually develop internal packages, or we can develop internal packages that are more specific, like, okay, this package will help me to analyze this data set or to make this process. And usually it is more about a workflow. So I take this data set from the database, connecting to that, I check something that we have all the patients, and then we run some kind of analysis, or we run some functions. I would recommend a blog post from Melanie Ryder that she wrote very well about how to make these internal packages. But these internal packages can be like also around a central idea, like a method that you develop, or you want to check something, or to develop a report. It's just not about making analysis. You can also make some about reports, or just a workflow salad of process, like what I say, checking column names and checking patients, or automatize some kind of process. And the point to write the packages is when the script becomes a little bit more complex. So when we have a project that is small, we can use a script with functions, and that's enough. And it's okay if we restore and we want to make it reproducible, it's great. But when the package, or when the project becomes more complex, we might need to write our own package. Here I link to one of packages I wrote for the project. And then there are also several other tools when we have a large project that we need to support with some other tools like Target or NV, Docker, to really make a project reproducible and to make sure that it works not just on our computer, but on others ones. So this package can sometimes be difficult to develop at the beginning, but it helps us because it forces us to think about the process and the results, so we can be more confident on the results and all the process that when we use it. It also helps to cut errors in advance and fix them in advance. That's also important to realize early on when we might miss something or some special condition, not just after we have done the analysis. And it helps us to automate repetitive process. So for example, here is an extract of REDCap that they were replicating 50 lines of code to interact with REDCap database, but now they extract all that, and then with just a function, you can do all this process that it took so many lines of code. And it's easier to maintain, it's easier to use for everyone. And also it reduces the effort long-term wise, because it's documented, you know where to go, and you have a central place where to find these tools, and it makes it a lot easier for you to use them. And when we use our packages and where we develop scripts, we use external packages. On these packages, we can depend on them. That it forces us to use that packages, and when we want to use our own packages, it must be that other packages like ggplot2. Then we can also import these other packages. So when we use some functions of the package, but not the whole package, we use them. And we can also suggest these packages. Suggest means that we don't need the whole package. We don't need them to install before our own package. It just, if you use some specific section of your package, you can use it. And this is what I would recommend to make it easier to install your package and to make it easier for all to use. And how to develop them? You can develop on your own computer and then share it on your with version control system on GitHub, GitLab, or just store there. You can develop and share on your organization through GitHub, GitLab, Slack, or any channel of communication you have. And maybe then some other people will join you and help you, because they might be doing the same process or not, or they might be interested that you could add something they do that they don't know how. And also it's usually very specific to institution, teams, collaborators, and it makes a little bit complicated sometimes to translate and coordinate all the interest of people that might be using this tool into something that works for everyone. So don't hesitate if you have some kind of issues with your other users to work out and develop and talk about how to solve these issues for everyone. And once you have developed this package, you have some users, they can install the package using the base RCMD install, using the tarball or the DevTools package that Emma already mentioned, installing from source, from the GitHub, from our universe or other places. You could even have your own internal CRAN-like repository, depending on your institution and your IT department, how they regulate all these kind of things of packages and sourcing and installing code from other machines. But this it's in order to help to make it reproducible, to have the same version for everyone, and to be sure that you are using the latest version. So just to think about how other users might install your package and talk also to your IT team. And last, once you have your package, you have developed it, and this is usually done in a burst at the beginning of the process on your project, and then you have lots of commits and changes, new functions. Then later on, people start maybe coming to your package, and then they make your flow go to one way or to another one. You may even need to move some functions, rename them. So be aware also that if you do that, to tell your users and be aware that these changes are the least disruptive that you can. And maybe you might even need to abandon a package and move on to another new package that might be easier for all the users, or is more general and it's not so focused on your specific project, and therefore more useful for everyone. But be aware that the life of a package is not just developing and writing code, but it's also interacting with all the users, and it can have a long life. And looking a little bit back to this long life of packages and how can we use them on science, usually we try to give trust, to provide trust to everyone. So when we report something, it's just a paper until it's report scripted correctly, maybe it's peer reviewed, and then we can provide code, and the code might be correct or not. That's true. And then we provide also the data to be sure that it can be checked. And then we need to check also if the methods are appropriate. And then there's the other publication, other analysis that might corroborate our results. And on all this process and trust process generating, and the packages can help us from the very beginning, from reporting. There are packages that just report things until the data provided process here. This is all the things that packages can help us. So they help us mainly to build statistical trust, but they can also help us build trust in reporting and all the process in between. Last, it's not complicated to have packages, as already mentioned. What it's more complicated is to be consistent and to help new people to onboard. When process change, database, some data change, some new projects start, you might leave, and then someone might need to take care of the package. But these packages helps to replicate, reproducible, and make all the analysis easier for everyone. Thank you very much. And if you have any question, we're happy to answer now.
Thank you. While questions may be coming through, there was one comment about nice call on the R universe. I'd like to ask you the question that I asked Emma as well, which was a very similar kind of enthusiastic call to creating packages. When was the first time you created a package? What was the reason for it? What kind of spurred you on to it?
I was trying to use some tool, and we wanted to add some method because it uses weighted co-expression network analysis, but it just using the expression values of the analysis. And I wanted to also look to similarities between genes by the functionalities they did. So I started developing a script, and then I realized that this could be more useful for others. And I created a package that went through bioconductor reviews for 5 years already.
Wow. Oh, sorry. When do you move from a few stray functions to take the leap to the package?
Yeah, that's a difficult question, and you need to think about how can be easier for you and on your users. Usually, I move to a package when there is more than one project that might use that. Or even if it's just one project, when I use the same function to several places, instead of having a source, the same script, I create a package and then I call the package everywhere. And then I know that if I modify this single function, I modify that for everyone, every place. So I'm more confident that everything works.
And extension of that, how do you know when is the right time to make the package worth the effort? So that's kind of the same thing. So you're saying when it's reproduced, when you know that you're going to need it somewhere else, you start moving it.
That depends. Sometimes you can do that for every analysis or every project. You have a project you have a package for every project, and sometimes it's not. There is no hard line, because also there is no hard line to share your script or your package. So it depends on also how much time you have to devote to maintain and to make it easier. Maybe documentation, you just write, okay, this is a function to analyze RNA-seq data. Okay, this is not helpful for future users or for future use. So maybe it's not worth to make it a package. But that's just, there are many constraints also in your time and dedication you can give to package. So that's up to you.
And I'm going to ask another question, which kind of then leads to the next one. Have you collaborated outside of your own analysis and your own research in other packages from other people's?
Yeah, lately I've been contributing to a package I use extensively on my thesis, and I've developed a package on top of them, and then I suggested some changes to their package and their methods to make it faster, and some are just simply comments about how to make or how they change they are making affects other users, like okay, this analysis, it's better, it's faster now, but this change of arguments, it's breaking my script. I will need to change everything, or this is great, but we were used to do that. Maybe you can send a notice or something like that, because if users keep using the same function, they will get different results. So that and this is usually done in GitHub or GitLab, but you also have on CRAN, you have the mails of the maintainers. So there's also a lot of correspondence, private correspondence there. Yeah.
Okay, that's wonderful. I'll wrap that up just to say thank you so much for coming virtually from so far away. It feels very international, and you're very welcome. And thank you so much for sharing this call to thinking about and moving towards packages, and encouraging us to also use our own community and talk to people and get help. And just that takes me to the next discussion, the next talk that we're going to have, which is a couple of analysts. Well, I'll say analysts.
Thank you very much.
Thank you so much. A couple of NHS-R community people who don't work together ordinarily, who have been working on the NHSRplotthedots, and that is the title of the talk. So it's going to be more than just that. I think there'll be more words around it. And it's Simon Wellesley-Miller and Chris Redding. I can see you both there. And you're going to talk about this new package that is on CRAN as well. You're on mute, Simon. Technical. I can see your mouth moving.
There you go. I'm through loud and clear. Excellent. Let me just sort out sharing screens. Yeah.
Oh, that's you.
Coming up now.
Yes, wonderful. Thank you.
Yeah, brilliant. I don't know who called it Plot the Dots. It's definitely called Plop the Dots unofficially. So that's where we are. Just introduce everybody who was involved. I don't know why. Let's get rid of that little thing. Obviously, you missed the things at the bottom. So about 3 Chris's, 2 Toms, Zoe and a David all got together, and I'll just sort of tell you the story of where we came from and how we got to where we are. So I will try to make it as entertaining and not so tedious as possible. So it started with our journey, which all started with a mug at the NHS-R Community first meeting. Chris was very enamored by a beautiful NHS-R mug and desperately wanted one, but Mohammed said, no, you can only have one if you write a blog for the NHS-R Community, which he then took the cup and also wrote the blog, which was around a very simple sort of SPC function that he put together. From my side, I guess I came along. I was very much into the sort of making data count agenda. We had the lovely Karen come along and do her lovely high-low presentation to us, and we were absolutely enamored by Plot the Dots, and sort of absolutely signed off and decided, yay, we want to absolutely SPC everything because it's amazing and SPC is really cool. Especially getting away from all those horrible RAG ratings and up and down arrows and all those sort of absolutely nonsensical things that we are asked to do. However, we were given this lovely little sort of SPC tool in Excel to sort of create SPCs. And for those who have used it, it does what it says on the tin, but it's really, really clunky. But it does come up with a few issues in that when you want to sort of do things at scale, it really, really falls over because it is a sort of a very manual process. So we put a shout out into the NHS-R community, trying to get some sort of support, and basically pull together a very much community-led project, and absolutely written by analysts for analysts. So we stopped, we collaborated, and we listened as per the words of the wise, and basically set about working on creating a package that would produce SPC charts at scale. Very much a labor of love. It was really nice to work on a project where there wasn't a deadline or there wasn't a target. It was very much, as I said, sort of a labor of love. We wanted to be able to have sort of more control over the types of charts that it produced, and absolutely the big one was, you know, scalability, be able to sort of run things at scale, produce lots of charts in one go, and automation was a major factor that we want to pull out, and like I say, change the sort of the range of options for outputs. So we created something that was going to be faster, reduce the numbers of errors between the keyboard and chair. The traditional copy paste into the Excel template did have some issues. So looking at what we've done, here's a few examples of some use cases. I pulled something together at the trust that I used to work for, putting together with our board papers, within the board papers, I think there's something like 72 individual SPC charts. Originally, they were all being created by individual analysts and then sort of copy pasted into sort of PowerPoint presentation. Use of this package has allowed us to sort of automate that process entirely, so that all the charts get created within R and then sort of pasted, or R puts them into a PowerPoint all automatically, calculates all the sort of limits and does all the stuff for you. Another thing that Chris put together was something around his sort of cancer site, and again, having that much more sort of live data and be able to sort of feed that through into sort of SPC charts much faster was obviously really handy. And this is an example directly from the SPC library that we have created. So I believe we have an amazing live demo from Chris, so I will pass you over to him for a second. How do I stop share? Stop share.
Is this where we're going to the seamless technological transfer of trying to share my screen from your screen?
They'll do the CGI bit over this, it'll be fine.
Okay, so hopefully everyone can now see my lovely RStudio panel.
Not yet. Oh, just doing it. Yes.
Have patience, Zoe. I know you're excited to see it. So
I am rather.
We've got a couple of example demos, starting from simple data sets going up to more complicated data sets, to show off what you can do with our plot the dots function that Simon has nicely led into. Did you have something to add, Simon, before I kick off?
No, you kick off and then I'll take off at the end.
So these examples all come from the fantastic NHS-R datasets source data using their A&E attendances information. So I will load our plot the dots package, and the first dataset that we've got pulls out some A&E attendance data for a single provider organisation, which, being completely unbiased, I've picked my own Acute provider trust. And we can then pass our dataset that we've created using a dplyr pipe into our key function, which is plot the dots SPC. It, at the minimum, expects a value field and a date field, and then we can also tell it whether the improvement direction for this particular SPC is an increase or a decrease. And with no further ado, we create our first SPC chart as simply as that. It's all compliant with the making data count plot the dots rules, so checking for outliers, checking for runs above and below the mean, looking for patterns of ascending or descending points. You can see that we also get, they're rudimentary at the moment, but we are working on improvements to the icons that you can get in the corners of the charts to show whether or not the recent points demonstrate common cause variation or special cause variation. We've tried to keep the look of the charts as visually consistent with the plot the dots Excel tool as possible. However, you can then, because this is a ggplot object, make it consistent with your own departmental theming and do whatever you like with it. So moving from the simplest example to the more intermediate example, if we wanted to pull in more than just my biased personal provider trust, we can have a look at an intermediate data set which has got a couple of other trusts in. And then we can add some more arguments to our plot the dots function. We can specify a faceting variable so that we can see multiple charts, and we can also use the helpful plot the dots target setting function to add target lines to our plots. So let's have a look at this one. So we've now got 3 SPCs created virtually instantaneously for 3 different faceted variables within our data set. You can see that we've now got red target lines that we've specified. You can use the really helpful plot the dots target helper function to specify target lines for each individual SPC, rather than just having to set one target line that would apply to them all. And we've also got, as you can see, this helpful plot the dots create ggplot function, which gives us more control over the presentation of the ggplot after we've done the SPC calculations. So for example, in this instance, I've moved the icons up to the top left instead of the default top right. You can change the default size of the lines and plot points. And I've reduced the number of x-axis breaks to 3-month intervals just to make the axis look a little bit less crowded. And then the final advanced example that I've got to demonstrate adds in even more provider codes and a few more interesting things in the ggplot helper function. So we're going to add rebase points here. So if I run the example, you can see that for particular trusts, we've done a rebase at a designated point in time, which can be different for each individual trust. So if you're examining particular facets within your data and you know that there are points at which you rebase your calculations for SPC, that can be done really easily within the plot the dots SPC function. And then I've done more exciting things with the ggplot helper function. So you can change the presentation of the dates from date, month, year into some prettier month and year arguments. And you can customize titles for both the X and Y axis and the overall plot title. So there's loads of stuff, both within the core simple plot the dots SPC function and the ggplot helper, that can allow you to really customize these charts so that you've got both immediate reproducibility and scalability of the plot the dots standard charts, but you can also customize them to the kind of charts that you might already be using with your organizations. And I'll hand back over to you, Simon.
Okay. That one, and that one. So thank you very much for the live demo. So where are we? We have had our first CRAN release accepted, so you can download this from CRAN into your R. As I said, we can do things like we can recalculate process limits, add in target lines, trajectory lines, and I think somebody was asking a question earlier. Yeah, it creates a ggplot object, so once you've created your chart, you can do anything you want to it, including chucking it through Plotly and seeing what that looks like. And yeah, we're just sort of working on the sort of basic construction of it. There is an option to pull out the actual data table that sits underneath the chart as well. So I think if you saw on the version that I had, I used the sort of official pretty icons. So what you can do, that's what I was supposed to say, working basic icons. What you can do is link to those separately using the calculations that the data table will pull out for you. And as I said, you can use this then to feed in to sort of link to real-time data. What do we want? We'd love some more feature testers to try to break it for us and see where the gaps are. Absolutely any willingness of or level of code to do it. Hopefully you saw from the very basic example, the real simple version was really, really quick and easy to use. And like I said, a couple of SORAR trainers, so we would like to add that into the national training at some point. And obviously cache is very useful. Where do we want to be? We want to create some additional sort of SPC types, looking at things like never events, some of the P charts, etc., which are sort of covered within the plot the dots, but we really want to sort of get the basics absolutely sorted out and obviously implement those improvements. We'd like to create a SPC web application. So again, that can just be used to sort of chuck data in and get a very quick chart back out again. And obviously we'd really like to promote the use of R, which obviously is what we're doing. And also sort of share this around as much as possible, either through AphA, NHS-R and the other plot the dots analytical community. And what was that? Sorry, that was, yeah, that's what we would like to be bathed in admiration. So what else we'd like to do? We're looking at whether we can sort of feed this into a sort of Power BI integration so that R can do all the heavy work and then BI can just plot it out. Like I said, we'd like to add it into our training. We'd like to do a sort of a fuller webinar on sort of more details on how to use this package rather than this very quick 2-second blast through. And I think that's it. So if there are any questions.
Well, yes, there were questions, but being an NHS-R community that we are, we've got people in the chat answering the questions from the team itself. So a lot of the things have been answered. There were questions over, I've kind of tried to do a summary. It was like action things. There was, just to bring it to sort of generic discussion, people wanted to know about how to get involved. And again, you answered that question, but actually, how do they get involved? There's encouragement to do so, but where do people go? Somebody did say, which was my involvement, which I haven't quite done yet, which is they love to break things. So they'd like to have a go, see if they can use it, break it, and then write up about it. So that was my involvement as well. So I'm glad other people do that too. Where do we go?
So hopefully that's up on the screen now,
Yes.
where the code stuff is, and also NHS, the Slack communities are a place to hang out.
And that's
if people have particular issues that they identify while testing the package, they can either raise it on the Slack chat that we've got, where all of us who've been developing the package are regularly discussing the finer points of the package, or you can open an issue on the GitHub page and engage directly on there and interrogate the code, maybe even open a pull request to offer alternative solutions and refinements yourself.
There was a nice thanks for doing the live coding. I think that was a nice bit too. So I just wanted to say that was really exciting. And there was a really interesting short discussion about commas and where they're placed. This is what we like, isn't it? This is what our discussion often was when we got together to talk about what we were doing. Just little details like this, they really matter.
My personal preference is commas at the beginning of lines, just because it makes it easier when commenting arguments in and out, and I don't end up scrolling along to the end of really long lines of code to check whether I did put a comma or not, and whether that's breaking my function.
Oh, I'm learning Python at the moment and trying to get my head around PEP 8, so commas are all over the place. Commas go where they have to go.
SQL for me, I put it at the beginning of the thing, and R, I put it at the end, just by convention. Start of line, someone says. Start of line SQL. It's hugely controversial, isn't it? We should have a talk just on this.
Blimey.
I would like to ask you both.
Anyway, wouldn't they? So
I'd like to ask you both a question. On a scale of 1 to 10, how much have you really enjoyed this? 1 being very little, 10 being a lot.
I mean, am I allowed to say 11?
8.2.
Oh, 8.2. There's always one, isn't there, that has to go to that like decimalization there.
No, it's been fabulous. Like I say, it's just been really good to have a genuine problem that I had within my trust, and actually sort of like say reach out to the community, and help organize, help test, help create something amazing, which is going to be absolutely fabulous. I was using a hideously long function which went over about 500 lines, and now that's been condensed to library plot the dots, and it's like, wow, that's just going to be a game changer. And if we can get that out to more people, that's fabulous.
I think from my perspective, it's been a fantastic opportunity to go from sort of a self-taught R coder, playing around, trying to create my own first initial functions, to the opportunity to, within a community, learn from people who've got significant package development experience, functional writing experience. Huge thank yous to Tom Gemma and Chris Maney for really offering loads of expertise to developing this, and Tom Smith getting on board and doing fantastic testing and function development. It's been a real team spirit.
And I'm just going to launch in there as well. And I've not actually contributed much. My name's on there, but I've added a few issues and just tagged along. And that's the thing about it.
You ask all the right questions, Zoe, to make us think.
But I think that's the thing as well, that you don't have to actually get into the nitty gritty of the coding or the statistics, because there are statistics involved, but you can still be involved. And I'm really grateful to everybody. I've always felt included in this. And I just wanted to extend that to anybody else who's interested in joining or adding things, that it's a really welcoming community, and this is an exemplar of it. And it's something, just to give this other advert, that you will be discussing more in a podcast with Chris Bealey leading on it soon. We are all going to try and get together, aren't we, to talk more about the package. It happened, unfortunately, and then half of it was lost because of technical issues, but we're going to do that again. So we will talk more about this as an advert for it. So I want to know as well, you're using this package yourself in your day-to-day work. Is that right?
Yeah.
And have you managed to get other people to also use it who are not too sure about using packages, or have you just kept it yourself? Or
I'm doing a demo next week to some people within my department to try and incite them to learn R. By saying, look, here's a practical example that you can use to massively speed up your workflow, rather than trying to encourage people to learn R in the abstract. I think it always helps to have an end product that you can use to tease people who are perhaps a little bit wary of learning a new programming language.
And I've started a job in the last 7 days. So found lots of lovely reports with hideous rag rated tables and all of that, which I'm going to burn with fire and drag them cricking and screaming into the plot the dots agenda.
Wonderful. We've just got a minute left. I mean, I'm thanking a team that I work with. I think it's been marvelous that you've got together from different organizations. We've never really worked together, but then we've learned a lot from each other for different reasons. It's been like a long-term hack, but was such an amazing thing.
I think just the opportunity to be able to work remotely and sort of network together and achieve this. Like, so I think I've met you in person, Zoe, but I don't think I've met any of the others actually in person, not knowingly anyway. So yeah, it's a fabulous opportunity. So get involved. Let's keep doing these things.
Yes, the comma discussion is still going on in the chat. Yeah, I think we could take this to Slack, and I think we can meet up later if anybody else is also interested. 2 to 3, we're going to be doing a question and answer, taking the discussion a bit further, get together with a cup of tea.
Next week is comma week on the Arch.
Yes.
On the Arch.
Yes. So with that, I'm going to give it, we're going to wrap up for this for the moment. Thank you very much to everybody who's been part of that, and for you specifically for coming to talk along today. We're going to have a 10-minute break, come a little bit sooner just to catch up, but the next talk will be at 12:30, and it's going to be just as good as the last few hours. So see you soon. Thank you, everyone. Welcome back, everybody, to the second day of the NHS-R conference. And the next talk that we're going to have is from Simon Moss and Richard Wood from NHS Bristol, North Somerset and South Gloucestershire CCG, on the use of PathSIMR, a package to support COVID-19 mass vaccination and stroke service centralisation. I can see Simon.
Yes, hello. Thank you very much for having me. Yes, I'll just share my screen a second.
Sharing.
Okay. Yes. Great, brilliant. Thank you. Yeah, thank you very much, everyone. So my name is Simon Moss. I'm from the Modelling and Analytics team at Bristol, North Somerset and South Gloucestershire Clinical Commissioning Group. I'm just like to give a quick note to my colleagues on this as well. So that was Christos and Rich, who won't be presenting with me today, but we're obviously very heavily involved with the work that I will be presenting today. So this talk's going to be about the application of PathSIMR, and PathSIMR is an open source tool built in R to model patient flow and capacity. And we're going to be talking through a couple of case studies as well as we go through. So just a quick word on the funding as well. So this work was supported by the Health Foundation, their Evidence into Practice Award. And the PathSIMR work was initially one of a number of advancing applied analytics projects. And the tool itself, PathSIMR, was developed in 2019. So there's kind of been two rounds of funding or development related to PathSIMR. My work comes in relation to the Evidence into Practice project, which involves promoting the tool, creating a couple of different case studies and embedding its use into NHS organisations. So just a quick overview of what we're going to go through in this 20-minute talk. What we're going to just do a quick introduction to PathSIMR, as I mentioned, and then we're going to look at two different case studies. So one was looking to improve COVID-19 vaccination centre operation at a couple of different sites locally, and then we're also going to look at our work to model flex capacity requirement for a centralised stroke pathway as well. And then towards the end, I'll just give you a little bit on further reading and information and links if you're interested. So just a little bit in terms of the background. So obviously it's going to be very familiar to many of you on the call that healthcare planning involves complex decision making around capacity planning, and kind of the crux of this is that insufficient capacity results in poor outcomes for patients, and too much capacity results in idle resource. And of course you've got the opportunity cost of that resource being used elsewhere. And some of the motivation for PathSIMR is that sort of the planning by averages approach, which is sort of commonplace within the NHS and other organisations, can underestimate capacity requirements by up to about 40%. So this little diagram on the right is this sort of chart on the right is a simple demonstration of what we're trying to avoid by using PathSIMR. So that kind of unsustainable building of queues at particular service points, which is brought on by underestimating capacity requirements. So just a brief background to PathSIMR. PathSIMR is based on a three-phase method for discrete event simulation, and the particular events that we're looking at. So we're looking at entry into the pathway. We're looking at arrivals into the pathway, I should say, and then entry into particular service points. We're then also looking at kind of the time that individuals are ready for discharge, and then we're looking at that discharge itself, so be that into different service points or exiting the pathway altogether. So PathSIMR makes use of user-defined pathways of both inpatient and outpatient services, so that could be bedded units, or it could be sort of different clinics with different that are operational for different times of the day. We can use time varying arrivals and capacity, so we might be looking at things like appointment slots, and also transfer delays. So if somebody's delayed going from one service to another because they need a package of care arranged or something like that. So the design principles for PathSIMR were co-produced with NHS analysts through surveys and workshops, and that was sort of a small part of the 2019 work which was brought to this conference a couple of years ago. The code is open source and in R, and its user interface is developed in R Shiny. I've got a link at the bottom there as well to the GitHub page where the code is sort of freely available for use. So then moving on to our first case study, which was looking at using PathSIMR to improve or sort of optimize COVID-19 vaccination centre operation. So sort of casting your mind back to December 2020, obviously the good news that the Pfizer-BioNTech vaccine had been approved for use in the UK led to a number of different live mass vaccination exercises across the country, and these were in a variety of locations, but obviously ones that were big enough to facilitate the large-scale vaccination. The initial kind of assumption was on 520 bookings per 2 vaccinator pod per day, and it didn't take too much work to work out that number was set too high. And I'll just briefly talk through the diagrams and images on the right. So the diagram talks through the kind of configuration of this vaccination centre in question. So we've got various different queuing points that were obviously designed for the registration point, the clinical assessment point, vaccination, and then obviously that large observation space that we'll all be familiar with for the mRNA vaccines, so Pfizer, BioNTech, and then later on Moderna. And above there we've got an image of Site A is kind of one of the queuing spaces there. So as I was saying, that 520 daily booking assumption that was made initially. So initially we worked out that was set too high, but actually the main work was working out what would be an optimal kind of number of daily bookings at the site. And in the end, we recommended 416 based on our simulation results. And this was then implemented at the site shortly after opening in January 2021. And actually, we had some really good feedback from staff at the site, including the lead nurse, with particular notes around how the 416 figure, the 416 figure, was a good balance between high throughput and site safety. And obviously, what that avoids, if we just sort of stuck with that 520 figure, is that avoids sort of queuing at various service points, and actually as a consequence that kind of would decrease confidence in vaccination and also appetite for vaccination. And you also have to think about some of the cohorts that we were vaccinating at that period of time, which were kind of the over 70s, over 80s, and also those who were sort of really extremely clinically vulnerable. So to have those individuals queuing in outdoor spaces in January 2021 with the weather in this country, not ideal at all. So the next thing we looked at was the transition to a combined design at the same site, and so site A was considering this, and I just want to talk through what we mean by when we're talking about a combined design and how it differentiates from a sort of separate design. So you can see that in the top right hand corner of your screen. So we've got two bits that sort of differentiate between those two. So we've got, as we saw on the previous slide, the separate design, which has the registration, clinical assessment, vaccination, and observation as different processes. And what actually changed with the combined design was that reduction in service points. So a combination of clinical assessment and vaccination at one service point. And as a consequence, that sort of led to a reduction in the number of queuing points as well, because obviously fewer service points leads to fewer queuing points. So the 2 combined service points were trialled at this first site that we'd done the work at initially, and we had done some on-site empirical data collection in January 2021, and some of that was around validating the work from the live exercise, which obviously didn't use real patients. Now we were looking at real patients coming in and going through this vaccination process. We were also engaging with staff at the vaccination centres, including the vaccination centre, including the lead nurse, to understand different constraints at the site in terms of both staffing and space as well. And what we were tasked with was looking at whether moving to a combined design would create consequences in terms of patient safety and queuing. And this kind of leads me to the plot on the right, really. So we were looking at whether we would, by moving to a combined design, whether we would exceed those acceptable levels of queuing that were defined by the constraints, the spatial constraints at the site. So you can see that that plot on the right, the sort of confidence interval for the number in queue isn't exceeding that acceptable levels of queuing, and so we could conclude that there wouldn't be any kind of negative consequences. So the maximum safe number of daily bookings for a traditional setup, when we modelled that, were 1,330, and the maximum safe number of daily bookings for a combined setup were 1,340. So again, for a number of different reasons, then a combined setup then was preferred and implemented in February 2021. Lastly, we sort of looked at the impact of disruptions at a second site. So this was a GP-led vaccination centre. So some of the questions that were posed were around late arrivals. So what if half of the booking scheduled for the second hour of operations arrived 1 hour late? And that's where we sort of come to these sort of quirky looking plots on the right, where we've got sort of the number in service dropping and then rising again in the third hour of operation. And then we can see what effect that has on the number in queue as well. And as you can see, the queuing increases to quite substantial levels. And so we could conclude that this sort of compromises safety. And actually, there's a question around where patients will be waiting as well. As we looked at earlier, some of those spaces, would be leading to outdoor queuing, which again, not good at all. The second thing we looked at was staff absence. So what if one of the 16 combined service points is unavailable for the first 3 hours of operation? And again, you can see that in the second plot on the sort of bottom right of your screen in terms of that effect on the number in queue and how that sort of grows quite dramatically before declining off again. So some of the potential solutions that were suggested to sort of mitigate against this were sort of lower daily bookings to provide slack or absorb shocks. And also additional reserve queuing capacity being made available as well. And some of this, obviously, these were hypothetical scenarios. So some of it was just around demonstrating to that second site the impact of some of these things and actually enabling them to start to mitigate against some of the, if some of these things happened. And obviously things like staff absence, sort of COVID rates and isolation and things like that, these were very real things that these sites had to consider. So in terms of the outcomes, impact and learning then, so it's easy to say with hindsight now that we know a lot about mass vaccination, but certainly in December of last year and January of this, we had very limited knowledge around the practicalities of mass vaccination prior to undertaking the work. And PathSMR, the R-based tool that I've been talking about, enabled really quick turnaround of simulation results in a time-sensitive and fast-paced environment. So it's worth saying that some of that early work we were conducting within days rather than kind of weeks or months. And if you compare that to some of the alternative solutions, i.e. building something from scratch or sort of procuring a different solution, neither of those things would have been quick enough to suit our needs. So having that sort of ready-made tool available was vital, really. So the simulation modelling helped to guide Site A in terms of those daily booking numbers, and also our learning evolved over time as new cohorts were eligible for vaccination and more sites became operational locally. So you can see the in this bottom right hand photo, this was Site B, so again quite different from Site A that we've been looking at some photos of in the previous slides. And actually towards kind of the slightly warmer months, we were looking at things like outdoor sites and actually sites that were sort of marquees and things like that. So there were a whole range of challenges and different situations that we had to look at and model. So then moving on to our modelling our flex capacity requirement for a centralised stroke pathway, I just thought I'd give a little bit of background for those who are not too familiar. So centralised stroke services can be cost effective, reducing mortality and length of stay, but because these often contain sort of a single unit at which people enter the pathway, you can sort of insufficient capacity will really affect outcomes, and there's nowhere else for patients to go. So it's vital that these estimates are correct. So local stroke service centralisation was proposed in 2020-2021 in our area. And the capacity assessments were determined in part using stochastic modelling. So just to bring your attention to this diagram on the right, so we've got the sort of current pathway, if you like, on it with A, and that has sort of 3 different sites providing services, but some of the key issues with this is the variation in outcome that people experience at each of these, and also the variation in access as well. So some of these sites were providing treatment at different times, and so if you're living in one of those areas, obviously that really is going to affect your outcomes depending on where you live. And then, as you can see, we've got the 2 proposed pathways below with B and C, and the main difference here, both of them contain a centralised hyperacute stroke unit, and then each of these 2 options, their main difference is the number of acute stroke units. So the first one, option B, has kind of 2 located at different sites, and then the third one, C, has 1 acute stroke unit based at the same site. So then moving on to modelling flex capacity. So the initial capacity limits for this work were determined through the averages-based approach that we've touched on earlier. However, these estimates, as we touched on, were likely to underestimate demand at peak times. So we had to therefore give consideration to flex capacity requirements along the pathway. And just to sort of give you a definition of what we mean by when we're talking about that. So the allocated capacity on the diagram on the right, you can see to the left we have allocated capacity. So that's capacity that is assigned specifically to that ward, and other patients can only be admitted if there's spare capacity. And this number, the allocated capacity, was used for that those kind of initial capacity estimates. What we've then incorporated at a later date is the flex capacity limits. So this is these beds are only used at times of peak demand, so when demand exceeds available allocated capacity, and they're sourced from other clinically appropriate wards. So they're sort of a temporary flex into other bed bases, if that makes sense. And the reason we wanted to consider this was to mitigate any negative consequences of underestimating capacity limits, and that's where the consideration of flex capacity can be useful. So in terms of modelling the proposed pathway, so we modelled two options, as I outlined earlier, for a proposed centralised stroke service. And as you can see in this diagram on the right, what we have, the dashed line represents the allocated capacity limit of sort of 22 beds at the hyperacute stroke unit. And then the final column is sort of 32 beds, so that sort of flex capacity limit with an extra 10 beds, and these limits differ at each of the units, and they were clinically led. So based on the knowledge of having one hyperacute stroke unit and one acute stroke unit on the same site, it was then clinically led as to what the flex capacity limit would be. And we looked at, without flex capacity, the hyperacute stroke unit would be full up to 89% of the time under the preferred option, and with that flex capacity model, the same unit was only reached that flex capacity limit 1% of the time. We also did some sensitivity analysis that examined the impact of kind of underestimating our input parameters. So what would happen if the length of stay that we assumed, if people were staying slightly longer, or in fact if some of those discharge delays that we had assumed between certain service points, if people were having to stay longer before being discharged, what would the impact of that be? So in terms of outcomes, and again, sort of learning that we picked up from this, so the proposed stroke services reconfiguration went to public consultation in June 2021. And as you can see on the right with a couple of images, sort of locally at least, it was relatively high profile. Simulation modelling outputs formed a key part of the pre-consultation business case, and the local clinical senate gave us some really useful feedback in terms of the PCBC being informed by robust capacity and demand modelling, and they actually noted the inclusion of flex capacity as well as being valuable, and that being a real asset within the modelling. Another nice thing as well was that the PathSMR's input parameters sort of matched the clinical view as to the moving parts of the pathway. So things like those delays that were modelled between different service points, those were found to sort of meet the real situation on the ground and reflect that. So finally, I think I've got a couple of minutes. I'm just going to talk through any sort of further reading and information that you might want to find if you're interested. So at the top here, we've got a couple of links to different papers, both on the mass vaccination work. So one published in June, and the others are preprint. So we've got those available to hand. We've also got some more work that's in the pipeline in terms of published work in terms of the stroke work that I've just mentioned, looking to submit some of that work, and also some work on psychiatric intensive care units as well, so modelling those. I've also got links here for the PathSMR code as per the GitHub link that I shared earlier, and also a walkthrough video which goes through how to use PathSMR with a particular focus on that RShiny user interface, and both of these are freely available. If you'd like further information about the Evidence into Practice project, there's a link to the Health Foundation's website just there at the bottom. And also, obviously, happy to take any comments and questions in the chat if we have time. But if you have any other questions or comments, please do feel free to email either myself, Rich, or Christos. All of our email addresses are there. And also, if you would like to find out more about our team and its work, we're also on Twitter at BNSSG Analytics. So that's everything from me. obviously, as I say, happy to take questions and comments. But yeah, thank you very, very much for your time.
Thank you, Simon. So it's wonderful to get an overview of an open source package that can be used throughout the world. So that's really nice. Thank you so much. There were a couple of comments. It may be things that you have actually covered. Actually, I wasn't too sure, or maybe want to get into the technical detail. But I'm going to have to move on, sadly. But thank you so much for a great talk, and maybe it can continue in the chat or later if we wanted like a Q&A thing that we're doing 2 till 3. You're very welcome to come along to that too. The next talk is from Will Yui, Principal Epidemiologist, Public Health, Hertfordshire County Council. Sorry, putting R into production. I can see you, Will.
Hi, I'm
Hello.
just trying to share. Hopefully
yes,
that
I can see your
working.
screen.
Oh,
Thank you.
first time. Yeah, so I'm Will Yule, as in Christmas, but not spelled the same. And as Zoe says, I'm a principal epidemiologist at Hertfordshire County Council. And Mohammed asked me to talk about our experiences of adopting and embedding R into kind of our workflow over the past few months. Asked for it to be inspirational, but I'm not sure if I can manage that, but I'll give it my best. So to start off, obligatory XKCD, but something that might be familiar to lots of people kind of moving into R. We were finding we had to do the same pieces of analysis again and again and again, with slightly different cuts of the data, slightly different geography or slightly different patient cohort. And we built this Byzantine structure of Excel and Visual Basic and Power Pivot and Power Query to kind of eke out any efficiency or reproducibility that we could, but it's very, very complicated. We had files all over the place that talk to each other. It's kind of a bit of a nightmare to maintain. And we turned to R for some analysis, which helped to a degree, but we were using R in quite a similar way to using Excel, really. We had things shared on saved drives, had relative paths to files and data sets and things, and basically nothing was reusable or functionized in any particular way. So very, very complicated. And really this gave us lots of problems about how to put things into production. So production being anything that's run repeatedly that the kind of business relies on. When you try and do that in things like Excel, you run into a whole host of issues, such as the inability, or at least a very tough time doing things like reproducibility and maintainability and collaboration, particularly. If you've got some massive Excel document that is really complicated and has 200 hidden sheets, let alone the kind of trying to get two people to work on it independently of each other, getting them to work on it at the same time as each other is basically impossible. But all of those things, or at least most of those things, are actually pretty straightforward, or at least well supported in R and with version control systems like Git and GitLab and GitHub, although we didn't necessarily know any of these things early on in our adoption of R. But in order to use R in that way, we had a number of challenges, and probably again they might be familiar to lots of people. So we had very limited access to R. It wasn't something that, open source software, always a risk, or at least is seen as always a risk. Not necessarily something that's particularly widely used in parts of the public sector, at least, although NHS are obviously changing that. And we could only access it with pretty low performance virtual machines that we didn't really have any way of speccing up or setting up things like our servers to disseminate analysis or do analysis on a bigger scale. Not that we even knew that those things existed initially. We also didn't really have the skills to use R and to make it clear that it was something that is worth investing in, because we didn't have the software, we didn't have the hardware. We couldn't build anything. Because we couldn't build anything, we couldn't demonstrate the skills to show what was possible. So kind of a bit of a vicious cycle. And for us, at least, and this one probably varies place to place more than any of the other ones, we didn't really have a culture of kind of adopting open source programming languages. There wasn't really a common language between analysts and IT, and adopting something like R wasn't necessarily high on the to-do list corporately, I think it's fair to say. And finally, kind of time. There's only so much time that you can dedicate to saying we should adopt this, and not necessarily getting very far. But because of COVID, the kind of time stopped being a blocker and started being a pusher instead, because suddenly, rather than not having the time to push for R, we didn't have the time to do any things in Excel because they didn't have the ability to really be put into production. So we kind of forced to bite the bullet and solve those challenges that we'd spent the past 3 months kind of prodding at, 3 years prodding at unsuccessfully, and not really getting anywhere. So initially, we were kind of pretty unaware of the range of options that were available to us. So we just tried to kind of upscale the things that we had been doing with a bit more rigor. So, using things like Git and version control, trying to use more functions and the like. And it went reasonably well. We were kind of automating some of the manual analysis that we'd been doing, and we're able to build a COVID model that Maddie from the team presented yesterday that was really, really useful. And we did some really, really big, complicated R Markdown dashboards in HTML that allowed people to kind of explore the COVID epidemic as it progressed, look at cases and look at how they related to each other, and view all of this information. But they might have got a little bit too big. So we kind of entered a little bit of production hell. So in July 2020, they started off at kind of a 1 megabyte HTML file that we emailed around each day. By September, it was 3 20 megabyte files, and then we had the winter peak. And by January, we were up to 380 megabyte files being emailed around every day. And a 10 megabyte HTML file is kind of, people can open it and interact with it, but by the time you get to 180 megabytes, you're probably struggling. I suspect the lifespan of our computers were severely impacted in January. And yes, probably by February, we would have had lost a few computers. So at that point, we kind of took a step back to look at what we actually needed, and how we could actually make changes. So we didn't really have working practices that embedded production and software and in what we did, and we didn't have software that made it easy to do things like reproducibility and maintainability. We kind of had pretty limited access to Git, and we didn't have any way to disseminate analysis other than email, which, as I've said, is kind of quite quick to break. So to solve these, we kind of needed to know what good development practices were, and also what software we could use to make things a bit smoother for all of us. And so to do that, we needed to invest in capacity and skills of the team, invest in the software, but also potentially before any of those demonstrate the value that we could get if we invested in analysts and invested in tools. So I won't spend too long on good practice because I think it's been done better elsewhere. But we kind of did lots of reading, did lots of playing around and making mistakes, and I think we're kind of moving towards a system that kind of works for us. And in general, we kind of decided that we want to move more to a functional programming basis rather than massive scripts, kind of adopting templates and using Git for version control. In terms of the software, this is where we kind of had no idea what we were doing at all, probably, to put it generously. So we looked at some different options, but didn't really know what the different choices were. So eventually did some digging and talked to people, and kind of came up with a list of options here, which was Give Everyone R, which is free in can't get better than free, but definitely wasn't going to work because you can't really get senior managers or people on the front line to boot up their computer and run a ton of R code. Also impossible to kind of distribute properly. We'd kind of played around with Shiny Apps IO, as I'll get onto in a minute, which is really cheap to do, can be free, and it's also really quick. But for us, it wasn't right because we couldn't use sensitive data on it, and obviously with COVID, a lot of our data is pretty sensitive. We kind of stick with what we were doing with standalone outputs around R Markdown documents and things, which again is cheap, as in free. But it doesn't scale or distribute well, as we've kind of gone across. You can do things like wrap Shiny apps in Electron to be able to distribute them. But at this point, we didn't know Shiny, let alone Shiny with Electron. So not really an option. And then the kind of more robust options are kind of involved setting up servers. So we did a bit of reading about Shiny Proxy, which is free again, which is nice. But as I've said before, we didn't have any of that kind of IT knowledge or Linux knowledge to be able to set up something like that. So for us, it wasn't really the right answer. And then we kind of stumbled across RStudio Team, which is for those who don't know, kind of a combination of RStudio Workbench, which is basically RStudio Desktop, RStudio Connect, which is kind of a deployment platform, and a package management platform. And for us, that pretty much provided the solution, but there were a couple of ways that we could implement it. We could either do it on premises, which again would need a decent amount of IT knowledge, or do it off premises, which would have a higher cost. And we ended up going with the off-prem solution because that worked for us. Obviously, other options are there. So to kind of demonstrate why we needed to invest in it, we developed a few key products that informed senior staff as well as those kind of on the front line, so they could become our advocates. So we kind of did a Shiny AphA dashboard, which was pretty responsive and much more user-friendly than our 118 megabyte HTML dashboards, and kind of demonstrated what was possible. So we could show you that, here's this Swish fancy thing. We can do something similar if we invest in analytics internally as well. We also were lucky enough to expand the team and undertook a number of internal and external training courses to build a kind of solid base, and a base that everyone had the kind of shared understanding of how to code and how to enable better reuse of code. And we started building our community locally with our obligatory pun-named Hertfordshire user group. And we've actually done quite a few local courses through that now, which has been really useful and enabled some joint work that otherwise wouldn't have happened. So that's been really good. And with that kind of those benefits demonstrated and the skills embedded, we were able to make quite a convincing case to get our studio team, and that with our limited capacity, we chose the managed service version of that. We fully adopted Git and GitLab for version control and project management, and started making templates and style guidance. I think it was really good to centralize on doing all of our project management on GitLab for us. It does have some weaknesses over other project management stuff, but it keeps it all in one place. And one of the things that we've started doing is packages and modules. And I think we've had other talks about packages today and previously as well. But I think one of the things that we've started doing more is using the box package, which massively lowers the bar. So my controversial statement for the talk is that code doesn't have to be wrapped in a package to be reusable. So I can highly recommend looking at the box package. Definitely coexists with packages, but as I say, makes it much easier to for want of a better word, package code that you want to reuse without having to go through the whole rigmarole of making a new package. And very good if you're doing internally focused development of things that enable your workflow. And that's kind of where we're up to now. So it's really, really nice. We've kind of got RStudio, GitLab Connect, and Package Manager all talking to each other. And that's massively simplified the process of putting things into deployment. You know, now we can click a button and then get continuous deployment. We code, do some testing, do a merge request, and automatically pushes a new version to the end user, which is fantastic and allows us to do things like beta testing and that kind of stuff. We can schedule automated data refreshes, use things like GitLab Actions to run automated scripts to do things like checking of code. We still have some issues with linking to internal systems, but it's reasonably minor and controllable. So in terms of what we'd wish we'd done earlier, so as I kind of mentioned, we kind of ended up building these massive dashboards. And what we probably should have done is look for some quick wins and make things on Shiny Apps.io, for instance, earlier, and demonstrate that potential rather than jumping into the big issues that we faced. So wish we'd used NHS-R Slack more, because once we started using that, we got loads of information about infrastructure, which massively helped us. And if we'd considered that production and infrastructure a bit earlier, would have been would have made our journey a lot more easy. And then finally, kind of functionalization and version control and documentation from day one. And again, I'll plug the box package because I think that's a great way to start the ball rolling on reproducible and modularized code, and kind of relates to some of the Shiny modularization as well. But yeah, that's where I'll leave it, which I think is all right for time.
Yes, thank you very much. I think that was an inspirational talk to what you thought at the beginning. I think you covered quite a lot in what many teams are hoping and aspire to, but in a very difficult situation with a pandemic going on, people wanting work probably a lot quicker than normal, which is usually quick.
Yes, it's both the blocker and the cause was definitely time.
Yes.
But yes, much better now.
There's somebody saying that they had a similar story to what they experienced in their contact tracing surveillance team in Public Health Northern Ireland, down to the software deployment solutions they chose and the barriers to implementation. So this is a story that's being repeated in various places. So it's heartening to read, but it's interesting to see that we have the same issues. And like with our Australian colleagues, we kind of hit those same issues. I'm quite interested as well, because nobody's actually asked a particular question, so I'm going to take this opportunity and launch in. Did you find it useful that you built up the R Markdown reports first and then moved to Shiny, or is that something that you're tending to move away from now and going straight to Shiny applications?
We as soon as we got Shiny, we thought, oh, Shiny new toy, so let's do everything in Shiny. But now we're kind of moving back a little bit, so not everything has to be interactive and on the server. It was definitely useful to have done that kind of minimum viable product development in R Markdown, because it made building the Shiny app a lot easier because we know what we needed to implement. But if we'd have done our public Shiny dashboard first to kind of demonstrate potential, we probably could have made the case for the server, 6 months earlier and saved me losing a fair amount of my hair over the past year and a half.
It's one of those things, isn't it? Learning from mistakes. We're all making it up as we go along, really, because this has never been done before. So we're really making waves. I also wanted to ask as well, is there no competing software, say proprietary software within your particular area, or was it Microsoft Excel really that you had access to?
It was, we were several years into a journey of adopting Power BI. So I don't think there was too much competition. There's little bits of Python around in the organisation, but they face the same issues as R did. And actually, one of the nice things about the solution that we've ended up with is that it supports Python as well, because it kind of brings them on board. So we can have one kind of data science platform rather than everyone having the same issues.
That's wonderful. Brought us to time as well. So thank you so much for, I think, quite an inspirational. It's inspired me anyway. There's lots of detail in there. You've covered so much ground, and I'm very interested to go over those slides at a later date and pore over them. But the next talk we're going to have now are from a couple of people from my trust. So I'm really happy to introduce these two. It's Hazel Kirkland, a lead pharmacist, and Chris Bealey, I don't need to look to the title, a senior data scientist from Nottinghamshire Healthcare Trust with the title Putting the R in Pharmacy, clever use of the R there again, forecasting and stock control using R for pharmacy inventory management. So welcome. I can see your slide, Hazel. The floor is yours. Oh, you're on mute. There we go.
Right, I'm just going to get my slides up here. I can see what I'm talking about. Brilliant. Good afternoon, everyone. It's good to be here. I'm Hazel Kirkland, as Zoe said. I'm the lead pharmacist for health informatics at Nottinghamshire Healthcare NHS Trust. I'm going to talk today about our project, so putting the R into pharmacy, which is has been funded by the Health Foundation Advancing Applied Analytics programme. So the aim of our project was to develop open source analytics to improve pharmacy stock control and to free up staff time, which could then be used for more patient-facing activity. So I'm going to give a talk about the background and from the pharmacy angle of the project, and then in the second half, Chris Bealey is going to take over and talk more about the technical aspects. So to give you some background, managing drug stocks is very time intensive and it's a very repetitive process. So within our pharmacy department, we've got a pharmacy stock control system. And within this, each drug has a reorder level and a reorder quantity set. And each day we run a program which looks at the current inventory level for each drug. And if it's dropped below the reorder level, it will then add that drug to the order at the reorder quantity. Now, staff also often amend the reorder quantity once it's been set. So although we have rules around how they should amend it, in actual fact, it can vary a lot depending on how conservative the particular procurement technician is on that day. We also have to maintain the reorder levels and reorder quantities for each drug. So every now and again, we have to go in and manually adjust those because to take into account the change in usage of that particular drug over a period of time. So there are two main pharmacy stock control systems within hospital pharmacies in England, and they do actually provide some basic algorithms to calculate the reorder levels and the reorder quantities. Now, these are based on average usage of the drugs. However, within our trust, we've opted not to use these, but maintain them all manually. Now, the algorithms that these two systems supply haven't been updated for quite a long time, and they don't take into account the more advanced analytics which retail and manufacturing generally use as standard these days. So within hospital pharmacy inventory management, we're kind of falling behind what is happening outside of healthcare. So the project was based on initially on a dissertation which I completed, where I tried to look at the complexity within pharmacy inventory management and I used some very simple forecasting methods to see whether I could improve on the average daily usage, which is currently used within the pharmacy systems. And I did kind of manage to actually improve on that, even with simple methods. So the Health Foundation then gave us funding to actually produce a practical solution, which we could implement within our pharmacy department. And to give you a bit of an overview, we wanted to develop a shiny app that for each drug would provide an order quantity and the number of days for the next until the next order. And the ethos was to develop and produce the final solution as open source, and Chris will talk about this later on. We also wanted the shiny app to be something which wouldn't just be used by our hospital pharmacy department, but could be used by other hospital pharmacies. So we tried to make the processes as generic as possible and to make the shiny app system agnostic. So it could, although we were developing it based on one pharmacy stock control system, we've been very conscious to make the shiny app so that it could also be adapted for use with the other pharmacy stock control system to try and maximise the usage across other hospital pharmacies in the country. So the workflow, it wasn't to replace the pharmacy stock control system, but it was something which needed to be used in conjunction with it. And the data is extracted from the pharmacy system database, and it's then manipulated. And this is the data layer, which is then used by the shiny app. So the shiny app is the user interface. So it's designed for the procurement technician to run. And where a drug needs ordering, it will produce an order quantity and, as I said before, and the time until next order. There does still need to be a sense check by the procurement technician because there is local knowledge which you can't just add into these algorithms. So there is a quick sense check, but the idea is that in very rare circumstances would they need to adjust anything. And then ideally, we'd want to import the order quantity back into the pharmacy system so that the order could then be sent across to the wholesaler. Although this isn't currently available at the moment, so we'd have to input manually until we actually got that set up with the companies. So the shiny app has an analytical tool within it, and it's a combination of forecasting, so that's based on historical demand, which Chris will talk more about, and an inventory management model. I'm not going to take any credit for the inventory management model. It was developed by Martin Utley, who's a Professor of Operational Research at UCL. And he actually supervised my original dissertation. So to look more in detail at the inventory management model, inventory management is actually very complex because there's no right answer to what is a right stock level. So it's a balance. If you've got too much stock, then you might not have enough space to store the stock. But it also costs money to have excess stock sitting on the shelf. So Lord Carter estimated that better inventory management could save £50 million within England as a one-off saving, just by reducing excess stocks on the shelf. And then if you have too much stock, there's also a risk that you don't use it in time and then it expires, in which case you just have to dispose of it. However, on the other hand, you don't want to have too little stock so that you risk running out. So if you've got a patient on a ward who's prescribed a drug and you don't have enough stock, then they're going to miss doses, which is obviously clinically very important. And we also want to take into account the clinical risk of shortages. So all drugs aren't equal in terms of stockouts. So the consequences of running out of insulin for a patient is not the same as running out of an emollient cream. So the whole inventory management model aims to balance the inventory levels against the clinical risk of shortages. So there's various things incorporated within the model. There's variable lead times, with storage constraints, a flexible system for order scheduling. So ideally we want to order a drug every 2 weeks. However, we might want to order it slightly earlier if the usage is more than we expected, or if the lead time was longer than we thought. And then we have risk aversions that we've put in there to make sure that we don't drop below the minimum level or exceed the storage capacity. And I'll expand a bit more on those things. So the inputs to the inventory management model are the forecasting. Then we've got the lead time distribution. So when you order a drug, the lead time is the amount of time it takes from the order to processing to the time that you receive the drug.
2 minutes, Hazel.
Thanks, Chris. When you decide, when you place an order, the order quantity order, it has to be enough to last until the next order is received. So we use historical lead times for each drug to create a lead time distribution, which then is used to calculate the probabilities of when the next order will be received. So we've got a minimum stock level in there. Now that is not like the reorder level, but it's basically emergency stock should the usage be higher or lead times be longer than we would expect. And this is based on historical daily usage, so it will automatically adjust according to usage patterns, changes in usage patterns. We've got a maximum stock level, so there are certain products, so intravenous fluids or controlled drugs, where we have a limited storage capacity. So we want to make sure the amount we receive doesn't exceed what we can actually store on the shelves. And then importantly, we've got risk levels. So these reflect an individual hospital's risk aversion, and they may change over time as more confidence develops in the system. So we've got a risk level which is a probability of the stock level dropping below the minimum stock level. So for example, your minimum stock level might be 3 packs, and you can set within the system, say, a 5% risk that you would at any point drop below that minimum stock level. And that can be, at the moment, it's an overall setting within the system. However, you can actually set it for each individual drug. So vital drugs you might set at a higher risk than something like the emollient cream. We've also got a risk level for exceeding the maximum storage capacity. So for example, you could set it at a 5% risk that you actually have more on the shelf than your maximum storage capacity. We have we input the current inventory level, just so we know how much stock's already there, and also the preferred time to the next order, which would usually be 2 weeks. I'm just going to very briefly mention the testing. So we've run simulations in R using historical usage data. That's not using any simulation package, just using for loops and if else statements. Again, we're going to be doing shadow testing against the current system to prove whether the inventory management model works, and then we'll move to a live pilot. And I'm going to hand over to Chris now.
Hello, sorry. Do you know my headphones actually randomly turned off at that exact moment? So I'm presuming that you just said, Chris, it's you now. So that was really funny, wasn't it? What a terrible moment that was. Sorry about that. That was absolutely terrible. Yes. Hello, everyone. Thank you. As Hazel mentioned, so I'm just going to talk about the sort of programming bit. So this is the sort of anorak moment for you all. Do you know I look a lot better on Zoom than I do on Teams? Right, I always get problems with backlight on Teams. So I just want to talk to you about kind of the sort of plumbing aspect of this. So I think the interesting thing about this project, from my point of view, is that as Hazel's made clear, there's sort of three people. There's Hazel, Martin, and me, and we all have very different kind of skills and knowledge within the project. And so I think one of the big challenges with this has been to all work collaboratively. So I really want to talk about that and how we've used kind of an open way of working in order to facilitate that. I must say at the top that I've been sort of watching the conference with mounting horror, to be honest, for the last 2 days, because I feel like the points I was going to make would have been highly original in the NHS-R conference 2 years ago. But now everyone's getting so good and they're all saying all the right things that I feel like you've all slightly put what I want to say under the shade, which is great. And I'll come back next year and try and say something even more inventive and original and brilliant than what I was going to say. So just to talk about some of the things that we did, Hazel sort of already outlined them, but from a sort of programming point of view, the database access is interesting because obviously the tables, this is a very large, busy, critical system. And so the amount of data involved is intimidatingly large. If you're looking, with a forecasting model, you might have, say, 3 years of data. That's an awful lot of rows of data. So like many of you, we've used the dbplyr package, which for those of you who are not familiar, essentially allows you to work directly on SQL databases by writing R code, because although I do speak a bit of SQL, my SQL's terrible. And my whole team does this. Is an approach that we do in our whole team, because we do interact with some big databases. So basically the R writes the SQL for you. So we avoid pulling the too much data into R, because it would take ages, and B, it would just break the entire laptop because there wouldn't be enough memory. And yeah, the forecasting. So the forecasting I didn't work as well as we hoped it would, which is disappointing. It works better than not doing it at all, without a doubt, and it works better than the averages. But it did not work brilliantly well, so I'm not going to go to town on that. But I did write some very neat and tidy code, so I can certainly talk about the fact that I did that. These are a couple of the functions that I wrote in the package. There's a GitHub link at the end, so if anyone's curious as to how it all works, then do go and take a look. Basically, the idea being that each of these functions it's the Unix philosophy of do one thing well. So we had a function for making the data kind of suitable for ingestion by the forecasting package. We had another one that actually did the forecast. Then we had another one that plotted the forecast, and so on and so on. And the idea of that, obviously, is, and I suppose that's my point in this talk, really, is that's how we work with ourselves, because it helps us to document and to understand what we're doing and all that kind of thing. But it's really, really, really important. This project has brought home to me how important that is when you're working in a team. So these functions that I've just mentioned here, so Hazel and I have both used these functions throughout. And that's good for two reasons. Number one, it means that Hazel doesn't have to rewrite stuff I've already done. But number two, it means, more importantly, that we're actually running the same code. So if we're not getting the same answers, then that it's a lot easier to debug problems like this. Just very, very quickly, I wanted to show you this just to illustrate that we're using the Fable package, which is a tidy implementation of Rob Heineman's forecast package of Your, which I have used. I have used the forecast package as well, and it's excellent. But this is what the cool kids are using now, and it's a tidy approach. I don't have time to talk about it really, but it's great. Go and have a look. And as I say, you can read the code. The stock control. This was Martin's bit, the inventory management. I didn't write any of this code, to be honest. I don't really understand it. But again, I did package it up very neatly, which is very satisfying. I think I did some very minor rewrites here and there just to make it a bit easier to use and a bit more consistent. And again, it's that same idea of, I think the naive way of doing this would be just to have, Martin's got a huge code file and Hazel's got a huge code, and we just copy chunks out of each other's. But we're not doing that. So when I write some more code, Hazel will just go to GitHub, she'll type install GitHub, blah, 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 faffing in and off of the VPN because it screws it up for some reason. And yeah, so we're all using this, so it saves time and it also increases reproducibility, which is what it's all about. Shiny, I haven't written a lot of Shiny yet. There is a bit of Shiny code on there. Just to say about Shiny, we're using Golem, which is one of my most favorite things in the world. Anybody who wants to talk more about it, please ask me anytime. Basically, it's a way of writing Shiny that, again, we all love in my team. And the core part of it for this talk is that Shiny applications written in Golem are themselves packages. So if you look at the code that I'm talking about, you will see that it is a package. It has package functions in it, but it is also a Shiny package. So it's a Shiny package where all the functions for the Shiny are all documented and properly, labeled and all that kind of thing. So that means that Hazel can write functions off the back of what's going into my Shiny, and that's key really. The simulation that she mentioned is using the same functionality that I'm putting into the Shiny, and it makes it a lot easier to make sure that you're all version control and doing releases and all that malarkey. So how am I doing for time? Yes, pretty much bang on time. So the take-home message basically is, number one, clearly, as I say, don't email loads of code files around, although, as I say, that feels a lot less original having watched all the excellent talks for the last 2 days, but there it is. Package and document your code. I absolutely hate it. I've read old Shiny applications that I wrote myself now from maybe a year ago, and I didn't document the functions, and it pains me because I can never remember how they work, and I find that very irritating. So do document your code. Write Goldilocks functions. So your functions need to be not too big and not too small. This is an art rather than a science. I think I've sort of got it right in this project. As I say, the idea being that Hazel and I can both use the same chunks to produce different results. So she's doing something and I'm doing something. We're actually doing very different things, but we're pulling the functionality that we need out at the particular time. And that's the GitHub link. So go and have a look. And that's all I've got to say.
Thank you very much. It was running just slightly over time, but that's because it was getting to the really nice technical geeky stuff at the end. It's a nice way just to keep going. There was no questions so far, but there's a point about working with SQL Server data and actually how tricky it is even working on using R on the SQL servers. So somebody suggested that they may blog about it, and I'd like to encourage people to share their thoughts on different kind of problems that they've solved or difficulties that they faced by blogging and sharing that information with us. There is a question now. Well, there are two. Is it a craft, possibly getting your Goldilocks function? It's probably magic, really, isn't it? Getting it just right, not too big, not too short.
Well, yeah. So I suppose really technically, I suppose people would say it's carpentry, wouldn't they? That's what they would say. I think that's the correct term. I have to say, from the message in the chat, I've heard this idea that you can run R in SQL Server. I believe it to be literally true. I've never seen anybody do it anywhere. It feels like the two-hour marathon. So I'd love to, please do write a blog post because I really want to read it.
Although it's a nightmare, someone say. Ooh.
Yes. Well, yeah. I want to see. I want to see the code.
What's the timeline to testing the pilot version?
End of the year, basically. We're going to be. Oh, sorry, Hazel, you come in.
Yeah, I was just going to say we're going to be starting the shadow testing in January, February, and then hopefully running live in March.
Wow, that's an amazing. I mean, it looks like a really technical accomplishment of such a very difficult, complex problem. It's not just one factor that you're sort of doing demand on. This is like all sorts of factors that need to be in there with different disciplines and different experiences working together. So thank you so much for sharing that as our final talk just before lunch. So we're going to take a break, quite a reasonably long break, because we're going to have this afternoon more, I should say, international colleagues. So we'll be starting at 3 for, I think, a start about 3:05. So if people were to come back or catch up later, we're going to come back here for 3 o'clock. So thank you everybody for all your talks today and your questions. It's been a wonderful day, and I'll see you later. Thank you very much.
Hello, can anyone hear me? Oh, good, thanks. Glad the microphone's working.
Hello, everybody. Welcome to the afternoon session of the NHS-R virtual conference. Can I just check people can hear me okay, please? Just a yes or a thumbs up would be great.
Yes.
That's lovely. Thank you very much. My name's Mohammed. I help serve the NHS-R community. But for the purposes of this session, I'm very much a student, really, of Professor Frank Harrell. So I'd like to give him a very warm welcome on behalf of the conference. I first came across Frank's work via the HMISC Harrell Miscellaneous Library in R over 20 years ago when R was a baby. And that library has been used the world over, especially if you're involved in biostatistics. And Frank's great book on regression modeling strategies is also one that is a classic in the field. I was just looking at the survey responses we've had on our annual survey, and one of the use cases that is described, I'll just share it really for Frank's pleasure, really. They say, we develop our packages that support predictive analytics at one of Canada's largest hospitals. The workflow uses Frank Harrell's approach to model building and tidy models. So Frank's contributions to biomedical statistics, both applied and theoretical, are far too many to enumerate, really. But an underlying theme, and this is, I think, the reason why Frank agreed to speak to us, is really Frank's commitment to sharing his expertise, his time, his advice, and the open source ethos. And so it's my great privilege and honor to welcome Frank. And I think we're in for a real treat. So over to you, Frank, please. Thank you.
Mohammed, I really appreciate the extra nice introduction. And it's really a great honor to be here, and I appreciate the invitation to present. So I hope you're seeing my screen share now. I thought I would talk about something a bit different, which is statistical mistakes. And one of the things that I've come to believe over the years is that teaching statistics is very hard. And if you're teaching statistics to someone who's been practicing medical research for a number of years, sometimes we have to unteach various things. And I found that it's much easier to teach people what not to do than it is to teach them what to do. And before making a list that I started several years ago and others I've added to, I wanted to mention that it's good to have various grounding principles that help you discover when something is really a mistake, or when it's really not optimal. And so I've listed here, this is from a blog article on fharrell.com, some of the fundamental principles of statistics. This sort of guides my thinking in a lot of different ways. These are written in general form. These don't really get into statistical details very much. But the first thing is really probably the least controversial thing, is to use methods that work. Believe it or not, there's a lot of methods being used in medical research that not only don't work, but have been proven not to work. So that's really not a good situation. So we need to show that something actually works, and simulation is the way to do it in sort of real world situation, but we have theory to guide us too. Understanding uncertainty. This is actually one of the hardest things for people to learn. And just one example of that that's mentioned here is you see a lot of papers where someone has assessed the data to see if it looks normal or Gaussian, or they've done a formal test of normality, and then they've made a decision based on that test. Well, that's actually a very problematic approach, and it doesn't take into account the uncertainty. In other words, the power of a test of normality is not 1.0. So to really have no uncertainty, you need to be able to detect non-normality every time it happens and not detect it when it doesn't happen. So that is just one example of a failure to understand uncertainty. Design experiments to maximize information. Understanding the measurements you're analyzing, don't hesitate to question how the underlying information is captured. This is the #1 mistake that a well-trained statistician makes when she starts collaborating with medical researchers, is she will tend to think, well, I'm fresh out of school. These investigators know what they're doing. when they said that you've measured heart failure a certain way, or you've measured severity of disease a certain way, they must know what they're doing. Well, a large portion of the time, they really don't know what they're doing, or they're doing something that's related to the truth, but it's a very inefficient capture of the truth. Be more interested in questions than in null hypotheses, and be more interested in estimation than in answering narrow questions. This really should guide how you review articles, how you publish articles and reports. It's a very general guidance. Use all information in the data during the analysis. This is one of my career's pet peeves, that I see this violated all the time. And so people are not respecting the raw data and how they analyze the data, and that is a loss of information and a lot of other problems that we'll go into. Use discovery and estimation procedures not likely to claim that noise is signal. This has been the bugaboo of genomics, proteomics, microbiome, and any kind of omics research. We're seeing a lot of unreliable signal discovery procedures still being used today, even in the best journals. Strive for optimum quantification of evidence, give decision makers the inputs they need, present information that in a way that's intuitive, maximizes information content, and is correctly perceived. Give the client what she needs, not what she wants, and then teach the client to want what she needs. So those are guiding much of what I do. And then we get into our particular topic for today, which is our list of problems, errors that are commonly made that that we need to avoid. So this is a website called datamethods.org, which is a site we created a few years ago that now has an international presence. And the site was created to be a place for methodologists and subject matter researchers in the health field to exchange ideas and to ask each other questions. And so we're getting some great topics on datamethods.org, including a lot of crowdsourcing of study design, which I really like. And I'd like to crowdsource more things to get more input from more people. But this is our author checklist. So this is a list of problems to avoid, or at least to document that you know they exist in a certain line of research. And this is an example of a topic on data methods that does have some comments at the end, but it's mainly sort of a wiki topic. So it's meant to be a reference topic. So this is our checklist for authors. It's also a checklist for reviewers and editors of journals. The Journal of Clinical Epidemiology recommends that this be used. And there's some links to a lot of references and some interesting topics that you might want to look at another time, including guidelines for reporting statistics, guidelines for figures and tables, and a really interesting topic on data methods called statistical myths. So there's a lot of common statistical myths. So you might want to look at some of those. So the first problem area that I go into here is design and sample size problems. We see a lot of use of improper effect sizes in planning research studies. One of the biggest mistakes that's made, and I'm still kind of amazed how often this mistake is made, is that people are using observed treatment differences in another study to power a new study. So if you look at how power is defined in the frequentist standard statistical world, the power is for an effect that you would be embarrassed to miss. It's an effect you would not want to miss. And that effect that you don't want to miss is independent of what's been observed anywhere in the world. So power uses an effect you don't want to miss. It never, ever uses an observed effect from somebody else's study. And if that other study was an observational study, you could be wildly off and wildly optimistic in making your sample size way too small in your new study. So these need to be based on real clinical knowledge about what's, say, a minimal clinical difference to detect, and it's not based on anybody's data. Relying on standardized effect sizes in planning a study is very problematic. It's been criticized a lot. This length paper is a good summary of criticism. Basically, standardized effect sizes are shortcuts that get you away from biological meaning or public health meaning. And so it's not a good basis for designing a study because it doesn't have any clinical meaning. It really is standardizing an effect according to how diverse patients are. And the diversity of patients is not of interest when you're looking at a clinical effect in general. Then there's general statistical problems, inefficient use of continuous variables. This is one of my greatest struggles, and we see this problem occurring every day, all year long, every year. And there's just so many problems with categorizing continuous variables, whether they're predictor variables or independent variables, whether they're dependent variables. There is a special topic on data methods that when you link here, you get into all of the many reasons why categorizing independent variables or dependent variables is a really, really bad idea. I used to think that it was okay to categorize variables for the purpose of making tables in a report or in a medical paper. And I've come to understand over time that making categories of things for the purpose of making a table is an absolutely dreadful idea, because I've seen tables that are just completely misleading, where the categories, let's say quintiles of body mass index or quartiles of age, where all the action is in one of those quartiles, and you completely miss it by grouping the whole quartile as if it was a homogeneous subset of patients. So even for making tables, categorization is to be absolutely avoided, which means you have to be making a lot more graphs than tables, because you can graph continuous variables. Relying on an assessment of normality, I've already mentioned that. And some people care about normality because they believe non-parametric tests are not very efficient, and that's exactly wrong. So non-parametric tests are more efficient than parametric tests, because when you have non-normal data, they can be much more efficient than parametric. And when you have normally distributed data, they really don't lose but something like 5% of the efficiency. So it's a very low loss, even under ideal situations for a parametric test. And this goes into this in a bit more detail. Parametric tests can be very non-robust. They can be greatly affected by one or two outliers. And the central limit theorem has no business being mentioned in this context. So the central limit theorem is a theorem for statisticians. It's not for practicing researchers. It has to do with a limit. And you can easily create data sets with 50,000 patients where the central limit theorem is horribly misleading because of skewness in the data. So you have to watch out for parametric methods. They do assume a lot. This one is less well appreciated. Fisher's exact test is not very accurate. So Fisher put the word exact in the phrasing of the name of the test, and that's really a harmful word. It's a loaded word because it's nothing like being exact, except in a very narrow sense that actually makes it conservative. In other words, the p-values are too large. And so we see a lot of medical researchers hung up on using Fisher's exact test in small sample sizes or small cell sizes. Not a very good idea. And the ordinary Pearson chi-square test works better, has more power, even under extreme situations. We see a lot of use of inappropriate descriptive statistics. So one of the worst cases I've seen is somebody said the mean hospital cost was $10,000 plus or minus $20,000. Well, that's just a statement that the hospital cost is skewed. That's a meaningless sort of interval. And just in general, for descriptive statistics, we like things like cumulative distribution functions and quantiles, because quantiles are always descriptive, no matter what the distribution, as long as it's completely continuous. You do have to watch out for what statistics you want to show when you're using non-parametric tests. Things get a little more complicated because the non-parametric tests are not really testing means or medians, but there are other location estimates, central tendency estimates that they are concordant with. The link here will get you to that. Failure to include confidence intervals is a real problem. So One of the ways to say that that I use to get people's attention is if you have a very small sample size, like we see in animal experiments and other laboratory experiments, you shouldn't be using statistical tests at all. So if you have an N of 6 or an N of 10, I think a statistical test is really a bad idea because it's not self-penalizing. In other words, the p-value will seem to be informative, but a big p-value means nothing. And laboratory experimenters will try to say that a large p-value is evidence for no effect, and that's not the case at all. A confidence interval in that case will be very wide, and it's self-limiting. So it tells you the limitations of your sample size by how wide the interval is. So a failure to include confidence intervals or Bayesian credible interval is a real problem. This is a very, very common mistake. Not as common as the next one, but it's still common, is using an inappropriate measure of change. So people will just plunge into calculating a difference from baseline, and they will assume that a subtraction is the right measure of change, or they'll assume that percent change is the right measure of change. And they will be unaware that the measure they've chosen is defective. And it may be defective because the change score was calculated on an improperly transformed variable. So you should have taken the square root when you took a log, or you should have left it alone when you took a log. And you find that your measure of change is still dependent on the baseline value. So we see a lot of improper change measures used. And then this is even more common problem. This is so irritating, and this is discussed on Twitter all the time. You'll see a lot of chatter about this. You'll see people calculating change in a crossover study, and that's not a bad idea because that's where change can be meaningful if you transform the data correctly. But then you see people using change in a parallel group design. Now that, I don't know who started the rumor that that was okay, but this has led to just countless wrong conclusions in clinical studies, including a lot of for-profit companies claiming that there is a reduction in some problem from baseline in the treated group when the parallel group comparison that the study was designed to do is not showing any evidence for a difference. So in other words, they will misinterpret regression to the mean as a treatment effect within the treated group and ignore the placebo or control group. And so when you have a parallel group study is designed to do one thing, and that's to compare parallel groups. It's not designed to compare change from baseline. Change from baseline can be completely and utterly misleading because of measurement error, regression to the mean, improper transformation of the variable, or assuming the slope of the post on the pre is 1.0. Change scores are not meaningful in a parallel group design. So a parallel group design gets a convenient sample from a population. It's used to estimate a difference between treatments, not a difference within a patient. So that is a very, very common mistake. We see a lot of mistakes in misanalysis of serial data or longitudinal data, and you can't analyze longitudinal data as if it was independent observations on different patients. We're still seeing repeated measures ANOVA used, even though that's been obsolete for more than 25 years. We see GEE used a little bit too often, although it's a fairly good approach. It's not always the best, but it's a lot better than treating the data as if the observations are independent. So you need to pay a lot of attention to how longitudinal data are analyzed, and it's best if you use a method that really respects the correlation structure in the data. Making conclusions from large p-values is one of the most common problems, and probably most of you are familiar with this paper by the great Doug Altman, who we lost 2 or 3 years ago, a giant of medical statistics. Absence of evidence is not evidence of absence. So we're seeing large p-values misinterpreted almost every issue of medical journals such as Lancet, New England Journal of Medicine. British Medical Journal is probably better than some. Journal of the American Medical Association is very guilty of this. You'll still see in the abstract of a paper that the treatment did not benefit patients. P is 0.7. So a P of 0.7 cannot be interpreted as the treatment did not benefit patients. The p-value 0.7 is that with our current sample size, we failed to obtain evidence that is disputing the assumption of no effect. So that's all that 0.7 means. It doesn't give you any evidence in favor of no effect. And Fisher, when asked what to do with a large p-value, he says, get more data. So there's no conclusion from a large p-value. This is a real problem, and I think it's a psychological problem and an economic problem. There are studies that are undertaken that cost millions of pounds to conduct, and a researcher doesn't want to submit a paper to the British Medical Journal saying we spent the money and we didn't learn anything. Nobody is brave enough or honest enough to say that, but that's what you should say in a large number of studies. The money's gone, and that's the conclusion, because the confidence interval is so wide that we can't really learn anything about the harm or benefit of the treatment. And so you should not be interpreting large p-values. Filtering is a problem more people are aware of. Journals are somewhat in tune to this. I noticed surgical journals not quite as in tune as maybe medical journals. But filtering goes on in a number of ways. You may not be analyzing all of the enrolled or randomized patients or subjects. You might be filtering out some. Of course, in a surgical study, filtering out those that failed surgery would be creating a huge bias. Filtering out different endpoints. So you might collect multiple endpoints and only report the ones that look beneficial for the treatment. That would be improper filtering. You might subset the follow-up interval and filter out late events because you think it's too late in the follow-up to be attributable to a treatment. That would be filtering. You might have studied more than 2 treatments and you just report on the treatments that are different from one another. That would be filtering. This is one of the most common problems of filtering that I'll talk more about, and that's filtering out variables in the analysis. Playing with the data to find different cut points for continuous variables is another kind of playing with the data. And all of this relates to intent to treat. In other words, analyze the way you randomize so you don't filter out any patients, and you shouldn't filter out other things too. We see a lot of poor analysis of missing data, and there is no magic cure for missing data. But our best default procedure is either multiple imputation or it is full Bayesian modeling. And for multiple imputation, this book by Steph Van Buren is sort of the Bible of multiple imputation. So we see still papers coming out where they've excluded patients that are missing on one of the variables being analyzed, and that can create a bias, or at the very least, it creates an inefficiency. So you need to be very careful how you analyze missing data. We know there's a lot of multiple comparison problems, and there's a lot of controversy about when and how to adjust for multiplicity. The dirty laundry of statistics is we don't have a recipe that tells us in a principled fashion exactly how you should adjust for multiplicity or when to adjust for multiplicity. It's a very, very, very subjective adjustment. And what is usually better than coming up with some sort of ad hoc multiplicity adjustment is to pre-specify an ordered priority list of hypotheses. And so if you were to report the results in this pre-specified order without any filtering and without any cherry picking, so even though your first most important endpoint has a p-value of 0.3, you still report it first. If your second endpoint has a p-value of 0.01, you still report it second. So if you report things in a pre-specified order, the readers will keep the context. They'll know that you're not cherry picking, and you'll avoid a lot of statistical mumbo jumbo. the New England Journal of Medicine doesn't understand this in the least, and they put out statistical requirements that are just bizarre. So they don't even let you report a p-value of a secondary outcome if the primary outcome was not so-called significant. I think from a statistical standpoint, that's just silly. And from a standpoint of advancing medical research and public health, it's beyond silly. This Cook and Farewell paper is the classic paper about this. Multiplicity considerations in design and analysis of clinical trials. They really argue for more of this approach here. And they make the statement that if you are asking multiple questions, you should be able to get multiple answers. But as long as you're pre-specified in how you do that. Now, if you turn to statistical modeling, there's just a host of issues. A lot of people are still assuming things are linear, and you really don't want to do that. You can't think of many situations where one variable should linearly relate to another. Even in the case of a pre-post design, we find a lot of nonlinear relationships between, say, the level of depression at baseline and the level of depression at 12 weeks. So even when you're measuring the same variable at two different times, you often get a nonlinear relationship. So there's no reason to expect things that are linear, so it's good to allow them to be nonlinear. We see this in a variety of ways. One of them is you'll see a machine learning expert write a paper showing that machine learning gives you better models than regression, like logistic regression. And if you look at how the machine learning person did their comparison, they forced all the variables to be linear when they did the logistic model. Well, that was a good solution when D.R. Cox invented logistic regression in 1957 or 58, but that's no longer a adequate way to do it. We've been allowing nonlinearity in logistic regression since probably the mid to late 1960s. So regression splines and non-parametric regression can relax those assumptions in a very nice way, and that will give you more power and better fitting models. Inappropriate model specification. There's a lot of model specification that is ill thought out. One of the examples that I see over and over is someone will ask the question, does change in weight affect your later health? And they will analyze, believe it or not, they will analyze the difference between the current weight and the historical weight and relate that to future events, find a significant relationship, and then they will write in their paper that change in weight is what predicts future health outcomes. And that analysis doesn't show that in any way. So what they don't do is just say, let's get the historical weight and let's get the most recent weight and use both of those to predict the future events. You'll find time after time that the latest weight that you measured is the thing that predicts the future events. It doesn't really matter how you got there. What matters is what was your weight when you started following the patient. And so that is a much more powerful predictor than change in weight. And it may be that the historical weight has a little bit of importance, but it won't have the same importance as the most recent weight. So that's an example of an inappropriate model specification because you're using the wrong variables and you're making a huge assumption that change in weight is the way to capture the two weight measurements. And it's very seldom the case that that is the way to capture them. Stepwise regression is one of our biggest culprits in all of statistics in terms of making non-reproducible research and poor research and poor models that will not validate. So there's some links here, such as Step Away from Stepwise, 5 myths about variable selection review and recommendations for a practicing statistician. And we have the Stepwise frequently asked questions. These are all super references, and we have compiled here a list of a lot of the problems. I guess that's the same as this FAQ here. The problems that are caused by stepwise regression are so severe And if you look at how genetics is usually done, it's really stepwise regression to the nth degree. So things just get far, far worse. But if you had to summarize this in a nutshell, you would say that you have a tremendous multiplicity problem, and the methods for finding the significant features do not replicate, they don't reproduce. So the chance of your finding the right variables is 0. And if you have collinearity problems, it's just even worse, no matter how big your sample size gets. So this is a method that was developed around 1960. It was implemented in statistical packages starting about 1964. And people keep using it because it's in all the software packages, even in R. And so this should be used with a warning every time the software runs to say, don't use it. Or here's the link to all the problems you're creating. It's a method that if it was invented today and submitted to a statistical journal, it would not be sent out for review. It would be rejected out of hand. And that's related to this. We see people, especially epidemiologists, for some reason, are saying if there's an insignificant variable in the final model, they did something wrong. Well, that's not true. If there's not an insignificant variable in the final model, then they did something wrong. So this is a very big misunderstanding related to the use of stepwise regression. Overfitting, which is related to overinterpretation, is another problem that is very common. And that's a lot of what my book, Regression Modeling Strategies, is about. We have some wonderful papers now led by Richard Riley in the UK about that show how to calculate sample size for getting a model that's going to be reliable. Overfitting is just a very common problem, and it occurs because you're looking at a lot of variables, and then you're looking at extreme predictions, and the patients for whom you predict high mortality, they don't die quite at that rate, and the ones that you predict have a very low chance of dying, they end up having a little higher chance of dying than you think. That's just overfitting. So that points to the need for model validation and doing everything we can to avoid overfitting in the first place. We see a lot of people trying to validate predictive models, and they're not doing it very well. So you'll see people divide predictions into deciles and make a bar chart showing the relationship between the mean prediction in the decile and the proportion that died or had disease. Well, that is not a calibration plot. That is a crude, a dichotomized or categorized plot that's very arbitrary, very inefficient, and it doesn't validate the absolute accuracy of your model. So you need to validate the accuracy of the model with full resolution. In other words, you need to make a curve that uses no bending of any type in the data that shows the predicted versus observed calibration curve is close to the 45-degree line. And when you're validating models, you need to use an appropriate measure of predictive accuracy. We see a lot of people using area under the receiver operating characteristic curve, which has a lot of problems with it, and it doesn't work well at all when you compare two models. It's not powerful enough for that. We see a lot of people using classification when they should be using prediction, and that is my most read blog article by probably a factor of 5, is the one that discusses the difference between classification and prediction. We have use of imprecise language, and we have this glossary of statistical terms for medical researchers and public health researchers that you might want to look at, and you might want to contribute to that glossary. So we're still seeing risk ratio used in place of odds ratio and so on. So we just have to be careful. We're seeing the word multivariate used in place of the proper word multivariable. So multivariate means you have more than one dependent variable. So you don't want to say multivariate when you have a univariate problem because you have only one dependent variable. There's a lot of issues with graphics. You could spend hours talking about that. And there's some advice here on how to make good graphics, and then some advice on how to make good tables. And then there's some miscellaneous things about what journals could do to improve statistical reporting, and links to a lot of other useful articles with guidance that are available on the web. And there's some reporting guidelines and lots of other guidelines. And the guidelines for reporting of statistics for clinical research in urology is one of the best statistical guidelines I've ever seen. Andrew Vickers at Sloan Kettering Cancer Center in New York led this effort. Absolutely stunning paper on statistical guidelines. And then a follow-up paper, and that was guidelines for figures and tables. I was involved in that one, and I would recommend both of these to you. So I think at that point, I think I'll stop and allow for some discussion, because I'm sure I've irritated some people and maybe hopefully given you some things to think about that you haven't thought a lot about. So I thank everybody for listening.
Frank, thank you so much. Yes, there has been lots of interesting comments in the chat. A few people have posed a few questions, just kind of seeking your kind of general advice in response to. So one of the questions has been that what do you advise instead of stepwise selection, stepwise approaches to model covariate selection? What would you advise as a better practice?
Yeah, I love that question. And I think the way to understand that is once we started using the phrase covariate selection, we got ourselves into a problem. And so it implied that selection is a good idea. And it's really not a good idea. The data do not have the information needed to select variables. So it started off on the wrong foot, and it just went downhill from there. And so the way that I like to summarize that in a nutshell is that everyone should be great at model specification. And model specification is so much more important and so much more safe than model selection. So let's quit thinking about model selection so much. Let's think about model specification and use subject matter expertise to strongly guide the model specification. And this is really referring to pre-specification without looking at the data.
Thank you, Frank. Frank, would you say a little bit more about that blog post, which you said has been read 5 times more than any other blog post, please?
Yeah, that's a blog article explaining the difference between classification and prediction. And it is explaining why classification is usually not what you want to do in the first place. So you see a lot of people doing machine learning where they're trying to classify patients as dead or alive. Well, when you think about it at face value, that makes no sense to try to classify somebody as dead or alive, because it was never the question. The question was always, what is the tendency to die? So given your age, given your severity of disease before you started treatment, what was your tendency to die? And tendency means probability of death. Or you could talk about life expectancy. So tendencies are actually the thing of interest. Predicting that this person's a dead person and this one's alive is really of no interest. And so classification is something that's interesting when the probability of being in one of the categories is greater than 0.99. So if it's almost a certainty, that is like when you're playing chess, when you're recognizing voice or recognizing handwriting, you have near certainties. Is this a letter L or is this a letter W? You have a near certainty in that. And so tendency for that to be a W is not interesting. You want to know, is it a W? So people have confused tendencies with classification, and they've just started out with the wrong task. And then they use a classification method, which is really a forced choice, which I call a premature decision. So classification is a premature decision. What we really want in the vast majority of cases, even in the business world, is prediction, not classification.
Thank you, Frank. Just a shout out to our colleagues on the call. If you do have any questions, please do feel free to post them, and I'll do my best to field them to Frank. Frank, just in the same way as you've just kind of dealt with the classification prediction question, Would you perhaps say a few words about prediction versus causal effects?
Oh boy, you sure you want to go there? I've avoided that topic as much as I can, and there are people who are experts in causal inference, but I do think that the causal inference world has tried to separate it too much from the uncertainty data analysis world, and so you really need to take into account that we don't know if a treatment is associated with a better outcome because there's uncertainties in the data. So you might have a Bayesian probability of 0.97 that there's efficacy, but it's not a 1. And the people doing causal inference say, well, if it's certain that there's an association, is it causal? And I'm not willing to ever say if it's certain that there's an association. I want to bring the uncertainties forward in the Bayesian sense. But causal inference, people are doing a lot of research trying to make that available to you when you don't have a causal design in the first place. In other words, you have observational data, and I'm not a big fan of going through the mental calisthenics that you need to do to try to get causal inference from observational data. I'm just not at ease with that, but I think I'm a growing minority in that sense.
Frank, thank you. Frank, you still are actively engaged in teaching. How has your teaching changed over the years, given the kind of things you've talked about today?
I think it's gotten a little more context dependent. So I used to in the old days make more blanket statements that tried to apply to all of medical research, and I find that things vary a lot, and especially by the signal to noise ratio that's inherent in your problem. The statistical methods you can do vary a lot when you have a controlled experiment with a really high signal to noise ratio versus a noisy data or observational data. The other way it's changed even more is I've sort of completed my conversion to Bayesian, to being a Bayesian statistician that David Spiegelhalter started me on the journey for back in the late 1990s. And so I'm interjecting Bayesian modeling into my teaching more every month and developing more case studies in Bayesian model, even starting with basic things like Bayesian t-test, Bayesian logistic regression, and just showing how you get so much more out of the analysis than you do with a hypothesis testing approach.
That's great, Frank. Thank you so much. Frank, I know you also do offer an online course that obviously anybody can join. I just a plea for anybody who's got a NHS.net address. That's also a poor public sector employee, Frank. So if there's any discounts for public sector, then .nhs.net would be very grateful for them. But I can highly recommend colleagues to try and enroll on those courses because there's some amazing stuff that's being described. Frank, I would like to thank you so much for your time, and no doubt we will reach out. I know you get many more invitations than you can possibly cope with, but if we do reach out to you again, please keep us on your list of on your list of possibles, please.
Will do, Mohammed, and thanks so much. I really enjoyed this.
That's great, Frank. Thank you very much indeed. I'll hand over to Zoe now, if I may, please, and ask Zoe to take our next speakers to the conference, please. Thank you.
Hello, thank you. And thank you for chairing that particular one. That was an amazing talk. Now, I haven't been able to check names, so I've been doing this using YouTube. So let's see how YouTube's gone with the names. I'd like to introduce the next couple of people. They should be starting at 10:02, so in a minute or so. But I'd like to introduce Gurgali Darochi and Urjay Gopal. Please do correct me. This was from YouTube, so it could be wrong. And from our studio, is that right? Is it? Yeah, this is our X studio. No. So Rix. How do I say that? Rix is probably the bit that I can't say. The Rix studio. Talking about our package and APIs for scaled personalized medicine. I'm going to let you just take this bit, and please correct me if I've got the introductions incorrectly. You've got a minute before you're supposed to start anyway, so we're going to start a little bit early. I can see your slides as well. Thank you so much.
Thank you, Zoe. And for those who are still on, it's hard to follow Frank, obviously. And we'll try to minimize any imprecise language as much as we can. If it's time, Zoe, can I start?
Yes, go ahead. That's wonderful. Thanks.
Thank you. Well, thank you to the NHS community for having us back. This is our second time in a row. And we're here to happily announce the release of our R package. These are client libraries to our APIs for scale personalized medicine. A little bit about us before we get started. I'm Ajay, and my co-founder is Gergely. I think Gergely, nod if that's the right pronunciation. Both of us have academic backgrounds and at some point moved over to industry, and most of our careers we have focused on what I call data-driven decision making at scale. So things like credit card decisioning, advertisement decisioning, etc. And we're now coming back to our kind of core passion projects around health and wellness. So with that, about a year ago, we started on the mission of RX Studio, and it was a very simple mission. It was to personalize every single drug dose. And we've been doing this by building clinical decision support tools with a specific focus on building recommendation engines that encode the latest known research in pharmacometrics, including kinetics, dynamics, as well as more recently pharmacogenomic models. And going to the next slide, the trigger for us to start this project was really this press release from last year, where Pfizer and Teva announced a global shortage of azithromycin. And this happened because there was, it was early days, first wave of COVID. Physicians were empirically, administering antibiotics, and that generated the first global shortage. When we looked at the problem and dug into the data, and most of the data you see on the left is based on 2019 statistics from the American Hospital Association report, what we found was a larger structural problem, and that is, and just high-level summarized statistics here. There are about 1 million drug dosing decisions made just in the US every day. And the impact of that, those decisions, which are done mostly based on manufacturer labels, is that about 7% of these as of 2019 will cause adverse and serious adverse reactions. That's about 50,000 patients a day. And if you look at the annual economic impact of that, we find that there's about 15 to 20% potential overuse of drugs in the U.S. economy, where there's about $200 billion of usage of drugs in a hospital context. That's about $40 billion of pharmaceuticals being wasted. But the real cost is really human life, and for those who go through adverse reactions, the cost of escalation and the trauma of escalation. It is estimated that to handle escalations from that 7% of adverse reactions, it costs the U.S. Healthcare system almost as much as all of annual drug usage, which is close to $180 billion in indirect costs. So we started thinking about this and recognized soon that the underlying problem was a structural one, and that is that pharmaceuticals have to do clinical trials, typically with tens or hundreds of patients, and publish a labeled drug dosage that needs a fair degree of generalization. Whereas most of how we respond as individuals is very, very subjective, and that the subjectivity gets lost. And most of the subjectivity comes from research that is done after the drug hits market, typically in an academic environment or a clinical research environment. So what we started doing was, in our platform, encode all the post-market research that is done into models that are made available at the bedside through the latest the computational methods in the cloud. And that's what RX Studio's platform really does. So we encode published peer-reviewed models, make them available as standard models. We also build custom models for specific cases. And we wrap that in our cloud platform, which is the topic of today's conversation. We provide input checks, the models per se, our simulation engine, which fundamentally is based on Monte Carlo simulations, and if there's therapeutic data, uses Bayesian statistics underneath. Gergely, if you could go back. The topic of today is the APIs, and the APIs provide an interface to all the technology we've built. And the APIs are what allow us to construct experiences around these models. So we have integrations with health record systems for physician use or clinical use. We have APIs that people are using for estimating historical dosage and accuracy, and the same APIs power direct consumer applications. With that, over to Gergely to the more interesting technology part.
Yeah, thanks a lot, AJ, for the context. Let me zoom into the technical bits. If you're interested in how we set up a cloud infrastructure based on R to power this application, please check last year's lightning talk and also an extended version at USR this year, where we covered this. But this time I will just focus on this piece, how to communicate with our modeling API that we have been doing for over a year from our front-end application and some of our partners as well. So we provided some documentation on the API endpoints in the means of Swagger or OpenAPI documentation, which includes like details on what this endpoint does, which journal articles have been used to implement it, changelog, all the required inputs, and so on. So our first idea was to use the Swagger code gen tool to generate an R package as an SDK, an API wrapper, so that we can very easily use it from R as well, not only using the RX Studio front end. And this is the end result. I have removed most of the code, as you can see from the ellipsis. Honestly, it's hardly readable, but it's not only about the internals. The generated code lacks a lot of the documentation that we intended to include and actually provide in the Swagger docs. It did not include the examples that we provided there. Also, just semantics. If you look at this function name, it's really difficult to spell. Like in the middle, there's this MC, which stands for Monte Carlo, and CFR, AUC, and so on. It's not really readable and usable. Also, instead of simulation for a function name, we would rather name it like simulate and then the drug name, PKPD target, and the method, and so on. So to keep it short, we decided to roll our own package, but for 70 plus API endpoints, doing this manually is just impossible. So we decided to do like a semi-manual approach. So we have written some functions that can generate the actual R functions and the package as well. And let me switch to this other tab so that you can see the package down documentation of this package. Let me go through a demo real quickly. First, you need authentication, which means that you need to register a free RX Studio account. Then you go to your profile page, create a long live access token, use the set access token once, and then you can run simulations as easily as in this example. Hopefully this is straightforward, like what kind of parameters we require to be able to run this, but let me click on this function to show you some of the details. Like if you're not sure what is creatinine for this function, you can see that you have to provide that in milligram per deciliter, what are the upper and lower bounds, all the other parameters are described in details, scientific journal articles, some examples, and so on. Also, just to point out a few interesting cases that I really enjoyed as an R developer to work on, looking at creatinine clearance cap, you can see here what values can be provided as part of our Roxygen documentation. Looking at the sources, which is auto-generated. So this file has been auto-generated, including the examples, all the imports, exports, and using the checkmate package to make sure that the creatinine clearance cap can only include these choices. Let me switch to RStudio, and I know kind of running out of time, so I will just do a quick demo and meanwhile starting this as well. You can see documentation provided in RStudio, just like you have expected. And when trying to run this simulate function call for voriconazole, you can see that we got an error. So checkmate captured that there might be a typo in the age. Try to run this for a 165-year-old person. So let me rerun this, sending a request to the API. So it seems that data validation has passed and everything looks good. On the other hand, this API fails with an error saying that the dosing interval must not be lower than the infusion time. And if you look at this example, you can see that the infusion time, so the third parameter was actually 15 here, which is greater than 12, which doesn't make much sense. So let me fix that typo here, rerunning, and this time, hopefully we will get the results in a few seconds and show you what kind of data and what structure is returned by the API that we can use from R and from the front-end application as well. So I got the same object. Let me just print it. You can see that in the viewer, some HTML page showed up with some ggplots and some not very nicely formatted tables because of the missing CSS, but we will fix that in a bit. Looking at the structure of the same, you can see that it's not only HTML, but including a lot of numbers in a structured way, like the suggested dose for this patient, or the population PK parameters, or in the Bayesian approach for the patient PK parameters as well. And also listing all the dosing regimens that we took into account for the simulation, including the one that we think fits the most this patient for the target PK/PD value, and all the other details like the minimum and maximum concentration, AUC ratios, and the diff from the PK/PD target. Let me just jump back here and show you how it's integrated in the application. So what we have run in R, that's also available from the front-end application as well, because it was running in the cloud. Now the version for the target PK/PD value. So now this is an interactive chart because it includes all the required CSS and JavaScript files. You can also export to PDF and so on. And what I just wanted to quickly highlight is calculating follow-up doses, going from empiric therapy to Bayesian one, including the loading doses that were suggested by the tool. But I know out of time, so let me go back, and AJ, if you can wrap up in 30 seconds or so.
Yeah, so our objective was to make the latest research, post-drug marketing research, available for the bedside. These APIs are our best shot at doing that. So we welcome you to create around these APIs any use cases that you can think of. From the conversations we've had so far, most of these revolve around antimicrobial stewardship, deciding when to end therapy, for example, localizing models to your populations, adding genetic priors, epigenetic priors, etc. And in countries without the clinical pharmacist profession standardization of care directly by as an interface to a physician. So we invite you to use our APIs. There are lots of use cases. We're happy to talk about it. This is how you can get in touch. Thank you.
Thank you.
Thank you both. I'm just seeing if there are any questions coming in. It's so nice that you came last year to the virtual event and then came back. Hopefully you'll come again next year, and hopefully it will be virtual again to keep this going, this conversation. This is I think it's also quite timely that lots of people are talking about packages. So thank you so much for showing that. And also, I know it's very brief, but also then maybe, is it online? Is it on a GitHub repo that we can have a look at? Even if we couldn't use it, we could also kind of learn from the way you've set out your functions and documentation.
Yes, it's online. It's on GitHub. The package is available for installation, and everyone can give it a try. It's free, so everyone's welcomed. Thank you.
It's just like it's all come together where lots of people have come, just put in the abstracts all about packages. This is what we're all talking about, it seems, today at least. There's a lot of things. So there are no actual questions on this, but thank you so much for sharing, and I'll move to the next person. And again, thanks to YouTube. I hope I get your name correct. Jeroen Ooms, and maybe I didn't get that right. Staff research engineer, got that bit right, from our OpenSci, and you're going to talk about the R Universe project and correct YouTube on my pronunciation.
Yeah, that's fine.
Oh, thank you.
Trying to share my screen here.
Yeah.
Shit. Zoom wants me to rejoin.
Oh no, technical problems. That's fine. We'll just fill in the meantime. We live in clinical use, 3 countries. Yeah, we're clearly international. This conference, we were last year as well. I think this is why virtual. I was talking at the chatting bit 2 to 3 that we met up today, and we were singing the praises of remote working. This bit where you have to connect is a downside, but remote working gives us access to the world. So welcome again.
Yes.
Yeah, sharing now. Wonderful. Thank you.
Decided to upgrade macOS yesterday. Bad idea. All right. You can see my screen.
Yes, we can. Yes.
No, I'm just trying to find it back myself. There we go. All right. So thank you for joining this talk. This talk is about the R Universe project. So R Universe is an ambitious platform by R OpenSci for publishing research and research software written in R. The platform is free and anyone can sign up, whether you're a novice R user or a student or a researcher or a professional package developer. Currently, we have about 350 registered individuals and organizations together maintaining several thousands of R packages and articles. And the main difference between R Universe and something like CRAN is that in R Universe, everybody owns their own personal repository. So therefore, there is no need for gatekeeping. So if you have some R code or an interesting R Markdown article that you think is worth sharing, regardless of what it is, you can sign up and publish that in your universe. So I will give a brief introduction about the project, but there's a lot that I won't be able to cover. If you want to learn more or sign up, the best source of information is the R OpenSci homepage. From our homepage, you can find several talks and blog posts that explain what's possible and how to get started. So first, a little bit about me. My name is Jeroen. I'm a staff research engineer and the lead infrastructure for R OpenSci. If you don't know R OpenSci, we're a research group based at UC Berkeley doing all sorts of things related to open science with R. For example, we organize peer review and we manage build infrastructure and a community for the use and development of research software in R. And as part of my work with R OpenSci, I also personally maintain quite a few CRAN packages. And these are mostly packages that interface to powerful C and C++ libraries that expose functionality to R that can be interesting for researchers. So what is R Universe? Now, R Universe is sort of an umbrella project under which we are experimenting with several ideas that we have developed over the years at R Open Sci to try to take open science with R to the next level. And in essence, R Universe is an open platform for publishing and discovering research and research software written in R. And the platform has many features and components. And at its core, R Universe provides everybody with a personal CRAN-like package repository based on Git, which is backed by a modern build system. So it allows you to publish packages with software, but also with other research materials, such as automatically rendered R Markdown articles. And on top of that, the platform provides extensive dashboards and feeds and APIs and metrics and so on to make the content more accessible and discoverable, both for humans, but also programmatically. So how does this work? In a nutshell, in R Universe, every user or organization has a unique subdomain under runiverse.dev for publishing their content. And the subdomain is mapped to your GitHub account name, which can either be an individual account or a team account. So for example, I publish my personal content under jeroen.runiverse.dev, and ROpenSci content is under ropensci.runiverse.dev. And on this domain, you can find a CRAN-like repository with R packages that are owned by this user or organization, and these include binaries for Windows and macOS in the same structure as CRAN itself has. And on the domain, you can also find articles published by this user or organization and a lot of other metadata. And when you open the domain in a browser, you can browse these things visually using a dashboard, but all of the same data is also available programmatically using HTTP APIs. And everything is automatically generated and updated from the user's Git repositories. There's nothing the user has to do. We automatically track the Git packages that the user has registered and sort of build and generate all of this content. So let's show an example. This is one that I really like. Here we see the GGSec universe. So GGSec is a suite of R packages developed at the University of Oslo for brain and cognition research. Most packages are maintained by Athanasia Mowinkel. And at the time of this snapshot, it consisted of 14 packages, one of which is also on CRAN. Actually, if you go to the dashboard right now, it has many more packages because they registered a few new ones. So again, the owner of the universe is the GGSec account on GitHub, hence the URL to the universe is ggsec.runiverse.dev. And the dashboard also shows some information about this user organization that's taken from the GitHub profile. And in the dashboard of the universe, you can see these tabs that you can use to browse the content. And these may change a bit in the future. Actually, right now, there's already an extra tab that I added a few weeks ago that is not yet in the screenshot as we sort of add new functionality. So let's look at a few of this content. So the builds tab is this first tab, and it shows an overview of recently updated packages, including the version and the maintainer and the date of the most recent commit. And it also shows this green badge when the package is also available from CRAN. And in the top, it shows example code for users on how to install a package from this universe in R. So users can easily copy and paste that. And so this column shows if binary packages are available for Windows and macOS, which here is the case for all packages. And from the color of the icon, you can see if the package has passed checks or not. And if there is no binary packages, you would see a red X. And as said, the top of the page shows example code for users, how they would go to install a package from this universe. And the easiest way is by setting the repos option in R, as shown above. Here we specifically set CRAN as the second repository, which may be needed for dependencies of the package. So if you run this code, it will install ggSec 3D from the ggSec universe, and the dependencies will preferably be taken also from the universe repository. But if they're not available there, it will fall back to installing them from CRAN. And as one thing to note is that if users install packages from our universe, they don't need to compile anything from the source on Windows or Mac OS. So just like when you install something from CRAN itself, all the packages in our universe are automatically pre-compiled by the infrastructure, and the user just can use install packages and things will just work out of the box. Let's have a look at the second tab, which is called Packages. And this shows some more detailed information about the packages, which are mostly taken from the package description files. So it shows the title and the maintainer and when the package was last updated. And if the package has a logo, this is also shown here in the dashboard. There's a few standard ways in which a package author can specify a logo in the package. And we use the same rules as the package down for finding the logo. But you can get much more detailed information through the APIs. Right, a little bit about articles in our universe. So besides packages, our universe is also specifically intended as a place for publishing articles. So in this third tab, you can see the articles for this given user or organization. And the articles get automatically rendered from our build system using the vignette system in R. But one difference between CRAN and our universe is that the intention of articles is not limited to software documentation. So as I will explain later, you can publish any sort of R Markdown article in your universe. And we specifically want to encourage researchers to sort of abuse the R package format to start publishing a research paper or a tutorial or a homework assignment as sort of a standard container format. So from the dashboard, you can easily browse these articles. All of the content that is shown on this dashboard is taken from the vignettes, from the packages from this user, and then rendered in a consistent HTML theme, which is the same across all users. You can also, so the top of these articles shows some information and some links, so that makes it easy to sort of link to these articles directly, either to the input R Markdown file or the HTML file. All right, so an important feature of our universe is that we provide programmatic access to all of the content and metadata in the system. So open science means that content does not get locked into some platform, but is made available through standard formats. So all of the data that I've shown so far from the dashboard, but also much more information about the packages and sort of metadata and metrics and all the information about articles can be retrieved through APIs. And the API tab in the dashboard shows some of the most important endpoints. So that looks like this. It's still under development, but you can sort of play with it. For example, the dash packages endpoint gives you all the artifacts and information in the database that we have about a given package from a given user. So this example, it returns all the data about the ggSec package, which here is a JSON list, where each entry is it's one of the package files. So in this case, there will be 5 entries for this particular version of this particular package. One is the source package, and there's 2 Windows binaries and 2 macOS binaries. And of course, you can read all of this information in R using the JSON Lite package or any other JSON parser. One thing to note is that these endpoints in our universe use the ND-JSON format, which is a streaming variation of JSON. So therefore, you need to use the stream in function. All right, so that was a brief introduction of what we have. So let's take a step back. Like, why are we making this? What is the who can use this? So I think there's several different use cases and different audiences that can benefit from a personal R publishing space. So the system is mostly built around the concept of R packages. So an obvious use case is if you are an R package author, but we really want to emphasize that an R package is really just a generic container format that can be used for software, but it can also be used for other research material. And in your universe, you can publish whatever you want. There's no policy on what's allowed or not. You can also publish some experimental projects, some research material, or some homework assignments. So let's have a quick look at some example users that are currently there right now and why they are using our universe. One use case is that you can use your universe as your personal R package portfolio. So suppose you've written a few R packages, some of which may be on CRAN or they may be on other places on Git. You can set up a universe to showcase your work and all of the things you're currently working on. Another use case is as a outlet for your research group. So here's an example of a research group based at the Imperial College London. And these are a suite of R packages mostly developed by Rich Fitzjohn. And most of these packages may not be suitable for CRAN, or it's just too much pain for them to like release everything to CRAN and deal with that. But by setting up their R universe, they have this nice coherent place where people can find the software that they are developing and sort of see what they are currently working on. Another use case for setting up your personal package repository on our universe is software curation, which is where this is sort of all originating. So in our OpenSci, we maintain a large suite of peer-reviewed and staff-maintained R packages, which we try to keep up to standard for use in scientific research. And so through the R OpenSci universe, it becomes easy for people to see activity and to easily install all of those packages without having to build anything from source and to sort of browse the articles that are currently being written by authors within the R OpenSci organization. But for us as R OpenSci staff, it also really helps as a monitoring tool, and we can keep an eye on the development and see which packages are actively being developed and which seem to be abandoned or failing tests, or packages that are maybe not actively maintained anymore. And finally, another use case is to publish the dev versions of CRAN packages. So if you are like this group, if you develop a lot of CRAN packages, sometimes users want to install a version of the package that is not yet on CRAN. So they can install it from GitHub, but another way is to install these packages from our universe, which again, the packages are pre-compiled. So it makes it much easier for users to install the dev version and the dependencies of a particular package. And another use case is to develop and maintain a set of interrelated packages for a given domain. So here is the R spatial universe, which has several R packages related to geographical spatial analysis. And there's many more examples. Like I said, there's about 350 right now. If you go to runiverse.dev, you can browse the webpage and see some examples. And one use case that I really want to re-emphasize is that we haven't seen much yet, but that we want to encourage is to really use the your universe for non-software R packages. So we are really used to think of R packages mostly for sharing reusable software, but R packages are actually a beautiful container format for like some code, some data, some documentation, some markdown documents, and you can use this for other purposes as well. So a lot of researchers have argued that R packages are a very good format to publish research compendia. So if you publish a paper, you can publish an R package which contains all the material, all the data, the supplementary code, and so on that is used to generate that paper, in the form of an R package, and you can publish it on your universe, and then sort of everything goes live, and you can live see the paper re-rendered with the current versions of the dependencies and so on. And I see I'm running out of time, so I'll wrap up. So then that is sort of the platform on the user scale. And then like GitHub, for example, the idea is that as a platform as a whole, we try to connect all of these universes, all of these different users. So on the website, you can see global feeds, which are show you the activity, the development activity across all the different users. So you can sort of see like across all organizations, what people are working on, which articles are being written, being updated. And on the maintainers feed, it's sort of an aggregate about the people. So the people that maintain these packages, which are especially interesting for package maintainers that are active in different organizations, and you can sort of see all of the things that they are working on. Right. So I'll wrap it up here. If you're interested, like I said, go to the homepage and on ropensci.org, and there you can get more information on how to sign up, how to set up your own universe, and see some of our future plans and so on. Thank you.
Thank you very much. Oh, it's dark. It's gone dark, so my lighting has gone.
Yeah.
Look all blues down. That's quite scary. NHS-R Community has its own R universe, which Tom has set up for us, and he does actually ask a question which I think is really pertinent, is on our own GitHub repositories, individual ones, we've used remotes installed from GitHub. Do you suggest we replace with the instructions with using the R universe instead?
Yes, of course. Yeah, no, I do think that does make it easier for users to install packages, because then the packages are pre-compiled and they don't, like, if the remotes depends on other remotes, then all of those, like the universe automatically pulls all of those things in. So it's one consistent package repository. And then for the end user, it is just as easy as they would install a package from CRAN, and they don't have to deal, especially in Windows and Mac, they don't have to set up compilers or like deal with other technicalities that they may not be interested in.
And another question was, do you maintain the tool set for installing R on Windows?
Yes, I also maintain that.
Wonderful. And a question that I'd have is, can you mix private with public repositories as well? So we do in our team use both, and we kind of need our own universe, but is that compatible?
That's currently very tricky, because the thing is really developed around the idea of open science and open source, and like everything is transparent. And so like for all of the packages in the universe, you can exactly go back to the source code, and our build system has to pull those things in, of course. So currently there is no notion of authentication at all throughout the system. Like we are really, at least right now, everything is built around the idea that this is really developed for public research software.
Yeah, that seems reasonable and should be supported. It's just getting there can be a bit difficult sometimes for us, but that's fine. And also just wanted to highlight that I just had a look at our NHS-R Community universe, and it highlights problems with some of the documentation, because my email address on one of them is incorrect. So if anybody's trying to email me, they've been trying to email somebody else, which is interesting. So I will wrap up for that. There's one on the question and answers as well. If I make a package with data and reports for a research project with different dependencies than the ones on the R universe, how do I organize the R universe?
Wait, I didn't get that question.
I think the thing is, if they're using different dependencies which are outside their own universe,
Yeah.
how do they organize the R universe because of the dependencies outside of it?
All right, so if the dependencies have to be either on your own universe or on CRAM. So basically the idea is that if your package depends on another package that is not on CRAM, just add it to your own universe. You can add as many packages in your own universe. So what a lot of people do is, if in their research group they develop some things, but they also make use of software that is developed by other organizations, just add it all in your own universe, and then you sort of gain control of this consistent package repository that contains all of the software that you use in your research group.
That's great. And on that note, I'm going to wrap up for today. Thank you so much for that. That's really exciting. And I'm sure that we'll do some more within our NHS-R community on the universe. That's it for the second day of the NHS-R conference. We'll be returning tomorrow at 9:30, again, also streaming live, and also, again, still available in the NHS-R Slack group. Thank you so much for everybody who came, international people and local. It's been a wonderful day, and I've thoroughly enjoyed myself. It's been great introducing everyone. It's been so easy. And thank you for the questions from everybody, and we'll see you all tomorrow, I hope. Goodbye and have a good night, or a good morning, depending on which side of the world you're on. Bye-bye.